but then stayed around as a drop-in for another 18 months or so before I really quit. So why'd I drop out?
कहाँ है तू? चलना यार, लेट हो रहे हैं। भाई
Good morning, one and all. Honorable guest of honor, Professor Dr. Jasavan Jena, Director, Institute of Mathematics. Honorable Director, Sri Soumyakant Balwantrai sir. Honorable Principal, Professor Dr. Sanjeev Kumar Das sir. Respected keynote speakers, delegates from different colleges and universities, USBM family members, and dear students. It's a moment of great privilege and honor for me to extend a hearty welcome to all of you today to the National Seminar on Big Data Analytics, Leveraging Data Mining Techniques for Business Insights. Our culture has taught us to start our day or any new task with the blessings of God. Now I'd like to request our esteemed dignitaries to light the lamp and take blessings of Lord Jagannath. I would like to ask everyone to please rise for the prayers. Thank you. Everyone, please be seated. It's time to start the seminar and to hear from the esteemed dignitaries. He's a man of distinct vision and fountainhead of illuminating ideas, an idol of knowledge, experience, and inspiration to all of us. It's my pleasure to welcome our principal, sir, Professor Dr. Sanjeev Kumar Das, sir, to give his inaugural speech. Sir, please.
Good morning to one and all present here. Honorable guest of honor, Professor Dr. Jasavan Jena, Director, Institute of Mathematics and Applications, esteemed Director, United School of Business Management, Mr. Soumyakant Balwantrai, distinguished delegates from other institutions, media persons, my dear colleagues and students. At the outset, I, on behalf of United School of Business Management, welcome you all to this national seminar. USBM has always tried to inspire minds with continuous development of skill sets through interactions with great brains from various walks of life. Today's national seminar on Big Data Analytics, Leveraging Data Mining Techniques for Business Insights, attempts to create a platform for the meeting of minds. The topic is related to a vast area which needs to be explored for the progress of the society. There is a huge amount of data created during the fourth industrial revolution. Such data generates by human through social media like Facebook, Twitter, LinkedIn, and Instagram, or by computer machines such as sensors, GPS, website, or application systems. The organizations are producing and storing the huge amount of data in the servers every moment. The Google, Facebook, Walmart are the most remarkable organizations are generating most of the data in the web servers. The big data analytics and data management is important in business intelligence for 4 reasons. Firstly, better decision making. That is, big data analytics can analyze past data to make predictions about the future. The business can not only make better present decisions, but also prepare for the future. The second advantage is cost reduction. Big data technologies such as Hadoop and cloud-based analytics bring significant cost advantage when it comes to storing large amounts of data. In addition, provide insights on the impact of different variables. Third is new products and services. With the ability to gauge customer needs and satisfaction through analytics comes the power to give customers what they want. Big data analytics, more companies are creating new products to meet customers' needs. And the last one is understand the market conditions. By analyzing big data, you can get a better understanding of current market conditions. Renowned academicians are present here to share their expertise. We can hope that some mind churning will take place and some positive findings will come up. I hope this national seminar can unfold several other aspects of data analytics which are still unknown and require a detailed discussion. I would also like to express my sincere gratitude to our esteemed guests who have accepted our invitation to grace the occasion. I would like to thank all staffs and students of USBM who have been working hard for the last 1 month to organize this seminar. Again, I welcome all of you and thank you.
Thank you, sir, for wishing us. We are extremely happy to have with us the man who has been instrumental in making all this possible. His vision and foresight have made this institute a premier one in the educational map of India. He is our beloved director, sir, Mr. Soumyakant Valvantrai. Due to his relentless efforts, USBM has covered a long distance and is still tall, walking gracefully. We welcome you, sir, to address the gathering.
Honorable guest of honor, Professor Jaswant Jena, Director, Institute of Mathematics and Application, esteemed invited dignitaries, respected principal sir, and invitees from other institutions, members of USM family, and my dear students. I wish a very good morning to all. It is my pleasure to be a part of this inaugural session. United School of Business Management has been working hard to make the future professionals corporate today. Our college has been doing relentless effort to nurture young talents so that they can face the challenges ahead. This national seminar is another effort in this direction. The role of big data analysis in business can never be overstated. Due to its speed and efficiency, it becomes a prominent part of business insights. I hope this seminar will open up new vistas in this direction. The interaction with the experts will certainly inspire the participants to work in the right direction. I express my gratitude to all the invitees for joining us and all the family members for their hard work to arrange everything in this grand way. I wish the seminar all success. Thank you all.
Thank you so much, sir, for your inspiration. Professor Jaswant Jena, our guest of honor today, is the Director, Institute of Mathematics and Applications, Bhubaneswar. As a mathematician, educator, and researcher, Professor Jena has contributed immensely to the society during his illustrious career. An alumnus of IIT, he has worked in various organizations, including Netaji Subhas Institute of Technology, New Delhi, in different capacities. His research papers have been the inspirations to many budding scholars in India and abroad. However, teaching has always been his first priority, as he mentions in an interview. We feel proud to have such a luminous personality as our guest of honor today. So without consuming much of our time, I would like to request Professor Jena to address the gathering. Thank you.
Honorable Director, Shri Balwantrai, Principal, Dr. S.K. Das, participants from different parts
of the state or country, faculty, staff, and students of this organization. I thank the organizers for inviting me to this event. Actually, in this talk, I want to emphasize how this data science or data analytics came into picture. If we go through the history, everybody, means all of us know that our highest degree is PhD. That is doctor in philosophy, not in mathematics, not in electronics, not in management, not in any other subject, but in philosophy. Why you get this, our highest degree in philosophy, not in our subject? We'll work, I have done everything in mathematics, but I will take a degree in philosophy. All my degrees I have taken in mathematics, except the highest degree. So why we get this degree in philosophy? Because this academics says, don't forget from where we started. Everything initially was under one umbrella, that is philosophy. And this philosophy later on divided into two parts. That is philosophy with proof and philosophy without proof. Without proof means we believe, we experience, but we cannot give the proof. Just like difference between a dead body and a person, walking person. What is dead body? Something was there, we say that is soul or Atma, but nobody can give direct proof of that. And similar thing, God exists or not, everybody believe, and before leaving our home, we do namaste, pranam, etc. So, all are some way believing in God, Atma, etc., so many things, but nobody can give us the proof. And the another part is with proof. From there started the subject mathematics. The subject mathematics started, the subject philosophy with proof. And after so many days, when the mathematician Newton came into picture, Newton, Leibniz, etc., they developed calculus, although this concept of calculus were used so many years before Newton and Leibniz in our India. All the temples and etc., all the structures were made using high-level calculus. But we Indians never write or never show up that we have found out this, or this is our contribution. That is our problem. So, but Westerners, whatever they are developing, they put it in documents. Now, anyway, people say Newton is the father of modern science, but he is a mathematician. What he did? The part of applied mathematics, that is termed as science. And after so many days, this science become, the concept of science were used in so many techniques. Then technology took birth during industrial revolution time. First was mechanical engineering, then civil, then so many branches of engineering started. Now, from 90s, just before that, this computer science and computer engineering started shaping from the subject numerical methods. Numerical methods, a topic from mathematics. What is numerical methods? When we stop moving ahead with analytical methods, we start numerical methods. Analytical method means we have limitations. We cannot find roots of so many, all types of equations. We cannot integrate all the functions. We cannot differentiate all the functions. We cannot solve all the system of equations. We have limitations. 2 by 2 equations, we can solve it immediately. 3 by 3 equations will take some time. 4 by 4 equations, 4 equations are unknowns. We can still solve. 5 equations, 5 unknowns, we will do mistake in plus and minus. These are 2 symbols. We learn it from the school level, but these 2 symbols disturb everyone. Plus, minus, nobody can say that we have mastered in these 2 symbols. जितने भी कोशिश कर ले, ये 2 सिंबल डिस्टर्ब करते रहेंगे, प्लस की जगह माइनस, माइनस की जगह प्लस, हम करते ही रहेंगे, मैं भी करता हूँ. Now, from these numerical methods, computer programming started, and unfortunately or fortunately, when I was a student in Utkal University, I learned Fortran for programming without seeing a computer. Computer कैसे दिखता है, how it looks like, we didn't know. But theory जैसा programming हम पढ़े जो अभी सोचने में भी शर्म आता है. हम पढ़ क्यों रहे थे उसको? That was the situation. And during 90s also, TIFR had a big IBM machine, and people were going to write their programs with punching cards. That time it was, they were using data, and that data was small. Small means if they were committing some mistake, then it was easy to capture. Suppose, what is data? In raw sense, suppose we are measuring temperature during some time interval. 1 घंटे के लिए हम टेम्परेचर नाप रहे हैं 0 to 60 minutes. Then, after each interval we have given 5 minutes, then we will note down the temperature of something. Then after some time, the nodes that the interval, that 5 minutes, and the observed values, both when we will take together, that is data. That is small data for us. Then next thing, that data I have collected, others may not understand that because these are only some numbers. Then next thing is how to interpret that. In numerical methods, we are using interpolation, curve fitting, etc., regression analysis, etc. We approximate this by polynomials, by interpolation, or we use harmonic analysis. We approximate these data with sines and cosines, that is by circular functions, harmonic functions. Those are easy. And if someone says that we have given 5 minutes interval, somebody says that what should be the temperature at 22 minutes, then we can use these interpolation or harmonic analysis values, then we can calculate that, predict that. That is approximate value. But small values, those are manageable. But when we talk about big data, then managing is very difficult. Another thing is storage. हमारे समय में इतने स्टोरेज कैपेसिटी भी नहीं था. P3, P4, P5 कंप्यूटर का जब धीरे धीरे जनरेशन बढ़ता गया, तब हमारा खुशी भी आगे जाता रहता कि हम कुछ स्टोर कर सकते हैं, हम कोई स्पीडीली कुछ प्रोग्राम लिख सकते हैं जिसका रिजल्ट हमको मिल सकता है. So this was the situation. Now we have very advanced computing system. जितने भी कंप्यूटिंग सिस्टम बढ़ता है उतना प्रॉब्लम से आते हैं हमारे पास. बिग डाटा and the concept is data mining. एंड जब माइनिंग की बात आता है, माइनिंग के साथ हम जब कोई भी चीज़ माइनिंग लाते हैं, माइन से कुछ भी चीज़ लाते हैं, उसके साथ कुछ इम्प्योरिटीज भी रहते हैं। एंड चैलेंज इज हाउ टू सेपरेट दीज इम्प्योरिटीज। सो there are so many advanced methods now available for data mining, and we say that data analytics. Then this also uses another term, leveraging, that we are going to use those parts which will give us direct benefits in business, etc. And next thing, what to do with other data? Are you going to keep those or discard or dispose? Discard means permanently remove this. Dispose means keep it somewhere. You may require this afterwards. And we Indians, we even don't throw, कोई पुराना कपड़ा भी कोई फेंकता नहीं, रखा रहता है कहीं पोछा के काम में लग जाए। तो हमें डाटा का क्या करें? सब फेंक दे, इतने तकलीफ से जो कलेक्ट किए हैं। ये भी एक प्रॉब्लम में आगे का आएगा। जैसे कि न्यूमेरिकल मेथड से कंप्यूटर साइंस से कंप्यूटर का कई ब्रांच, आईटी, अभी सॉफ्टवेयर इंजीनियरिंग एक्सेट्रा, कई सारे कंप्यूटर ब्रांच से निकल के आ गए। जैसे मैथमेटिक्स से साइंस, साइंस से टेक्नोलॉजी, टेक्नोलॉजी से कंप्यूटर साइंस से कई सारे ब्रांच निकल के आ गए। अभी डाटा साइंस भी कंप्यूटर साइंस का एक बच्चा है। अभी मुझे ये इंतजार है कि अभी ये डाटा साइंस का, डाटा एनालिटिक्स का, इसका कब कितने बच्चे आगे आ रहे हैं। बहुत जल्दी आ जाएंगे। इसका छोटे छोटे ब्रांच हम उसको भी पढ़ेंगे, स्पेशलाइजिंग, बिकॉज दिस ए वास्ट एप्लीकेशन इन ईच पार्ट ऑफ लाइफ, बिजनेस पीपल, अमेजन, फ्लिपकार्ट एटसेट्रा, और मैकडोनल्ड्स, everybody, they are taking our data, collecting our data, they are looking at our moods. हम फेसबुक खोलते हैं, हम जो जो चीज़ देख लेते हैं, आज एक बार दो बार देख लिया, उसके बाद फिर फेसबुक खोलेंगे, उसके रिलेटेड कुछ एडवर्टाइजमेंट हमारे पास आ जाएगा। कौन देखता है? कौन उसको एनालाइज करता है कि हम क्या करते हैं और हमारे नंबर के साथ कैसे जुड़े रहते हैं? दिस इज वेरी चैलेंजिंग टॉपिक एंड पीपल, और इसका फायदा भी है और कुछ नुकसान भी है। पीपल आर एंगेज्ड इन अदर एक्टिविटीज, फ्रॉड एटसेट्रा। अब ये डाटा के साथ कोई खेलते हैं तो बहुत अच्छे काम भी कर जाते हैं, रियल वर्ल्ड के लिए और सबके लिए, ह्यूमन काइंड के लिए, ह्यूमंस के बेनिफिट्स के लिए बहुत कुछ काम हो जाता है। और कुछ बैठे हुए हैं हैकर्स एटसेट्रा, वो भी हमारा डाटा का भी उनके लिए जो सही है वो उसी तरीका इस्तेमाल करते हैं। सो डाटा, द चैलेंज इज स्टोरिंग डाटा, सेफ्टी ऑफ कीपिंग required information, processing techniques, and keeping these data safe for us. कोई ना कोई आएगा कभी। अभी पहले सोने चांदी का था कीमत, अभी ये डाटा का ही कीमत है। हमारा डाटा बहुत पैसे से बिकता है, हमारा फ़ोन नंबर, हमारा मेल एटसेट्रा। अभी हम थोड़ी देर से पहले बात कर रहे थे। सो we have to take care of the things, how to analyze data for our benefits, and throw out, dispose or discard data which are not required, and keep the processed information safe so that it should not be misused by others. So once again, I thank the organizers. Thank you all for listening to me. Jai Hind.
Thank you, sir. We extend our heartfelt thanks and deepest gratitude to Professor Jena for gracing us with his esteemed presence as a guest of honor today. Your unwavering support, wisdom, and guidance have made this event truly exceptional and memorable. Now, I would like to request our Honorable Director, Sri Somyakan Valvantrai sir, to felicitate our guest of honor. Thank you. So now we are moving towards the end of this inaugural session. So I would like to request Shravani ma'am to propose formal vote of thanks. Thank you.
Honorable Professor Jaswan Jena sir, esteemed Director sir, Principal sir of USBM family, distinguished speakers, faculty members, dear students, ladies and gentlemen. I stand here before you with a heart full of gratitude to thank all of you to be present in this inaugural session. First and foremost, our heartfelt gratitude goes to esteemed Professor Dr. Jaswan Jena, Director of IMA Bhubaneswar, for joining us and enriching this inaugural session with your valuable insights and wisdom. Sir, thank you. A special note of thanks to our esteemed Director and Principal of USBM family for their tireless efforts in fostering an environment of excellence and holistic development for our students. Thank you, sir. We would also like to extend a heartfelt gratitude to all of our faculty members and esteemed keynote speakers to be present in this inaugural session. Thank you for your valuable time and presence. And now we move forward to the technical session, but before that, I would like to request the volunteers to delegate the dignitaries to guest room for the tea break. I would also request the volunteers to be present and escort the dignitaries to room number 104. Good morning, ladies and gentlemen. A warm welcome to the seminar again. Please be seated. We are delighted to have you all on this national seminar of Big Data Analytics, leveraging data mining techniques for business insights. Now, without further ado, let us begin the technical session. I would like to call upon the volunteers to present the bouquets to esteemed dignitaries. Volunteers? Can we have a huge round of applause for all of the keynote speakers? Thank you. Firstly, it is my privilege to introduce Professor Dr. Samarjit Kar. He is an eminent researcher, author, and currently a professor in the Department of Mathematics, National Institute of Technology, Durgapur, India. He holds a doctorate from renowned University of Vidyasagar. His current research interests include operations research and optimization, soft computing, machine learning, and uncertainty modeling. Dr. Kar has published over 180 referred articles in international journals and authored 6 edited books. And he has been cited for more than 7,000 times in Google Scholar and has appeared in prestigious several journals. His academic collaborations are spread all over the global south. He is also an active participant in Chinese academia. He is serving as an associate editor of OpSearch and is the guest editor of IEEE Transaction and Fuzzy Systems, Sustainability, Symmetry, and several mathematics journals. Thank you, sir, for being present today, and I would like to request you to please be on the dais for the further notice. Well, anyways, we are very delighted to have you, Samarjit, sir. Now, I would like to, it is an absolute pleasure for me to introduce Professor Dr. Subhashish Mohapatra, sir. He's currently working as an assistant professor in the Department of Computer Science and Applications and head of the Department of Computer Science and Engineering, Odisha University of Technology and Research. He has more than 20 years of teaching experience in academics and administration. He holds a doctorate from NIT Rourkela. His research includes cloud computing, distributing systems, evolutionary computing, Internet of Things, and healthcare. He has published for more than 20 Scopus and SCI indexed international journals and more than 30 Scopus indexed international conferences. He has also published 4 design patents. He has also received various recognitions and awards in his teaching career. He is an active member of international conferences and various assignments. Sir, we are delighted to have you. Please be on the dais to start the technical session. Thank you.
PPT will be directly, we will directly start the PPT. As faculty members and dear students, so it's my privilege to share some of my experience and knowledge regarding the big data analytics, leveraging the data mining techniques for business intelligence or business insights. So before going to the slides and detail about this big data analytics, data mining, data science, data analytics, business intelligence, all this detail. So first we will come from the real life, how we are facing this type of technology in our real life. So most of us, we are going to supermarket, and some of us also we are going to unit 1 market. So all of you are acquainted with this. So who can differentiate what is the difference between a unit 1 market, or simply we can say hatto, and the supermarket? Then we will come to our technical topic. What is the difference between these two concepts? Anybody of you can have a wild guess? Why we are saying it's a supermarket or super bazaar, and why we are saying it's a simple bazaar? Any wild guess? No. So the basic thing is that whenever we enter to the supermarket, we get the things in a structured manner. Clear? So it makes our access of a particular item more simpler. But if we go for a common bazaar, then we can get the product, but the access of that product will be complex because that has not been properly arranged. We may not get the items nearby. Suppose, one example, I am searching for bread and butter. I should get milk nearby this because these are the associated products. Correct? So, supermarkets are basically using the data analytics concept for their inventory control, identifying the important customers or valuable customers, how to promote the products to valuable customers, how to give discount to different type of customers based on their transaction history. So these are the things related to data analytics. Whenever 5 number of customers are coming to the supermarket, how the manager predict out of 5, 4 customers or 3 customers will purchase, others 2 have just for visit, how they predict, how they accordingly arrange the products, how they will control the inventory. So all these complexities basically we can solve with the help of data analytics. Clear? So coming to our slide, so first I will give you some of the, you can operate over there. So first I will discuss what is data. So these are the basic flow of the presentation, introduction to data and its importance. Because nowadays data is most of the, one of the, simply we can say most operating term. And data analytics also is one of the biggest domain on which most of the companies are recruiting people for data science or data analyst. Clear? So next one is introduction to data analytics and analysis, how the analytics is different from analysis. Next we will discuss how it is related to business system. The next one is data analytics life cycle and building blocks. What are the core concepts we require to develop a model for data analysis? The next one is data mining, how the data mining helps for business analysis process or analytics process or decision making. The next one is, I have given one of the example because I have been working on this particular field last 10 years, right? Healthcare sector. Basically, we have published also many papers in Elsevier and HCI, that is breast cancer detection with the help of AIIMS Bhubaneswar, because the oncology department is associated with. We have collected some data and we have also worked on that. So apart from the breast cancer detection, we are also currently working on heart disease prediction. We have used some of the static data that is present in general repository Kaggle datasets. Apart from this also, we have implemented some of the test bed like smartwatch, from which we can collect the real-time data. We can store some real-time data somewhere else, and we can take the real-time decision that I shall showcase. So next one is proposed model simulation test bed, result discussion and selected references. So coming to the first point, what is data? In data structure we are learning data, fundamental of computer science we are learning data, and now the data is one of the upcoming subject. So anybody of you can define what is data? Because it's on board. Wherever you go for shopping mall, they are asking your phone number, your name. You go to airport, they are also asking, submit your Aadhaar number. Why they are asking your Aadhaar number? Because from the Aadhaar number, they can extract all information about you. Yes or no? Correct. So who can define what is the data? It's very simple definition. Data means value or set of values. Clear? It is a simple value or set of values. It can possible two students can have the same name. Yes or no? Two students can have the same address, can have the same phone number. They are staying in hostel. They can have the same account number, joint account. So they can have the same account balance also. So how can we distinguish two students having almost all the characteristics similar? So we require a unique information, unique value, that is the registration number. Is there any students having no registration number? Is there any students having same registration number? No. So we require some of the value through which we can distinguish the students. So similarly, Aadhaar number now in digital age, Aadhaar number is the only attribute through which we can distinguish two customers, two employees or two persons having almost similar characteristics. So why analytics is required? Basically, we are analyzing the data for future possibilities. By analyzing the previous transaction, the manager can predict that who are the products that are frequently required by the customers. So accordingly, he will make the inventory arrangement. Clear? So analytics is the discovery, interpretation and communication of meaningful patterns or summary of data. So next, coming to the data analytics, it's nothing else, it's a process. It's a process of examining data sets in order to draw a outcome, right? By observing some of the transactions or by observing some of the patterns, we take a decision. Why the students have secured less marks in X subject? Whether the students are not properly provided sufficient staffs, whether the question pattern is difficult, whether the evaluation process is difficult, or any other factors. That means these are the parameters for which we have to collect the data. After that, we have to analyze the data. Then we can take a proper decision. This is the reason why the students have poor performance in this particular subject. This is known as data analysis, not analyst. That means something has happened and we are drilling down why it has happened. Correct? But analyst means what type of steps or what type of precaution measures should have taken care to get better result from the students. So we have to improve some of the seminars, or we have to improve some of these educational strategy to improvement of the particular subject skill for the students as well as the faculty. So that is all about the analytics part. So data science is one part of data analytics, which is the process of using data to find the solution for a problem statement. So we can say the data analytics or data science is not restricted to only business process. It is spanning from healthcare to education to real estate to military services to many domains. You can find out I have written agriculture, transportation. It is spanning for all sectors. Next. So this is a basic type of data, because whenever we are collecting the data, some cases the data are quantitative, some cases the data are qualitative. So it is very difficult to handle qualitative data. Suppose I am asking whether a male or female. How to make it quantitative? If I can make it, or if I can translate into quantitative, then I can frame a model for that and I can implement that particular quantitative data for a particular model for any type of predictive purposes. But if it is a qualitative data, then it is very difficult to handle. So it is not necessary that always we are handling qualitative data. Some cases also we are handling images, figures, facts, that can be considered as different type of data. As I discussed, we are considering the breast cancer detection. There we are not considering data, rather than we are considering some of the images, right? So data are basically classified into 4 different categories. Nominal, you can see male or female, 0 or 1. Ordinal, that means different student grade level, E, O, A, B, C, that type of data. Interval of data, that means we are collecting the body parameter, because most of you are acquainted with the smartwatch. You can find out how many number of steps count, how many number of blood pressures that is being recorded through your smartwatches. So that comes under the interval beta. Then ratio is the weight age. Usually that remain constant for a long duration of time. So how we can make the data, how can we say that data are important for us? So it can be used for many different aspects. First one, it helps in better decision making. How we can see that data can be helpful for decision making. If you consider about the banking sector, bank is providing loan to the customer. So they have make a strategy. What type of, how many number of loans are there? Suppose there are 3 types of loans: short-term loan, mid-term loan and long-term loan. So which type of customers will be provided which category of loan? So they have make a strategy for that. Whenever a new customer is coming, then he is giving the requisite data, and the data need to be processed by any of the bank officer, so that he can take a decision whether he is eligible for getting a loan or not. Correct? So second one is solve problem by finding reasons of underperformances. That is also another aspect of importance of data. Next one is helps in evaluation of performance, helps in improving the process. That means we are collecting the feedback from the customers. Most of you are acquainted whenever you are purchasing a product through Amazon or Flipkart. After that you have to give some feedback regarding the product quality and service, right? So next one is it helps for understanding the customer and market. What is the requirement of customer nowadays? Everybody is trying to purchase a bike with high cc, high mileage, which is not possible. Or I want to purchase a car with high comfort, low cost. Can it be possible? No. So we have to synchronize either of this part. Either I have to increase the budget or I have to decrease the sophistication, so that I can able to fit the particular model that is being available. So if you'll go for the analysis of data analytics, it is defined as the scientific process of transforming data to insights for making better decision. Why we are saying it's a scientific process? As I discussed, we are using some of the numerical methods, some of the mathematical models. After that, we are translating these models to any of the programming concept. Then we are using that particular program by providing some of the data sets, and we are getting some decisions, or we are getting some results. So importance of data analytics basically for credit risk, efficient way for delivering products and services. The common example is online service. You are well acquainted with this. Next one is preventing fraud identification. That means one of the concept we are using in data mining, that is known as outlier detection. Outlier detection. That means suppose I shall ask you the age of your batch student. Most of the students suppose belong to 22, 22. Suppose unfortunately I had some of your age at 60. Correct? So usually that is known as a outlier, because none of you belongs to 60 age. So that type of, I give just one of the example, but that can be considered as outlier for identification of the frauds. Next one is uncovering the cyber threats and returning the most valuable customers. As I discussed, suppose some of the customers are purchasing the monthly grocery from the supermarket. Some of them are random customers, they are purchasing the products. So how the manager will identify who are the customers they are frequently coming to the supermarket for purchase purposes, right? So what type of provisions we can make so that other customers will be insisted to come and they will make the same track record of the previous customers. So for that they are also using some of the concept like network analysis, right? In network analysis, what they do, suppose I am interested for purchasing different type of shoes, right? So they analyze the network. So who are the other customers associated with my network? So automatically they post some of the advertisement or discount of the products to the network of my system, so that automatically they will go for promoting that products directly or indirectly to the network. So that is also one of the important aspects of data analysis. So data analytics, it is defined, already I have defined this process. So how it is different from data analysis? So analysis is the past, or it basically explain how and what had happened, but analysis represent the prediction for the future. So data analytics, how it is helpful for the business process? So there is no specific domain that is not related to business process. If you will consider healthcare, that is a business process. If you will consider education system, that is also a business process. If you will go for agriculture system, military services, any domain that includes the business strategies. So basically the first one is to enhance the customer experience. As I discussed from the transaction history, we are observing the different type of patterns. What are the order of purchase of the products by the customer? Suppose out of 10 transactions, we observe that most of the customers are purchasing bread, butter, then milk. But rare customers are purchasing bread, butter, egg. So we will not consider bread, butter, egg as a pattern, but rather we will consider bread, butter, milk as a pattern. So that accordingly we will make the cluster. You just imagine, suppose there are 10,000 number of products are in the supermarket. So how they are making the cluster? Are they calculating manually? No. So they are using some of the sophisticated methods by finding the correlations and association of the products, so that they are making a cluster of the products which will helpful to the customers to locate the product in a faster way, and they can give the better quality of service to the customers. So next one is make informed decision. And third one is reduce employee turnover. Next one is improve efficiency. With the help of data science or data analytics, we can also improve the efficiency of the system, because we don't have to manually calculate, or we have to use some of the complex algorithms or complex problems for decision making purposes. Identification of frauds, improved advertisements, and better product management, as I told about the association clustering of the products. Next one is handle the complex problems which cannot be calculated manually, right? That part we will discuss by taking some of the examples. The next one is conducting the competitor analysis, because if you consider about the business process, same product is being produced by different vendors. So how we will give the better quality of service, and we can give flexibility to the customers, so that the customers will adopt the product, right? We have to sustain in the market. So that's why we have to take some of the decisions. With the help of collecting the feedback from the customers, we can integrate this particular feedback in the model, so that the model can give a proper decision, what type of necessary steps can be taken care, so that the products can be promoted properly. Next one. So these are the data analytics life cycle. So first one is problem identification. So whenever we are developing a model for any type of problem, so first we have to find out what is the problem. So we can identify the problem by comprehensive study. That means simply we can say the literature survey or related work. Then performance reporting and questionnaires. Questionnaires means by discussing what type of problem is there, how to solve this problem. This type of discussion we have to make for solving a particular, suppose why the sales is decreasing in rainy season, why the sales of a particular product is decreasing in rainy season. So we have to find out some of the parameter, what are the attributes that affect this particular sales ratio. Next one is hypothesis formulation. So after problem identification, then we have to make a hypothesis. What is hypothesis? That means we have to consider, suppose one of example, whenever a customer is purchasing a laptop, he is supposed to purchase a external drive. It is not necessary that all customers will purchase, but it's a pattern that we have discovered from the transaction history. That means whenever one person is purchasing a laptop, he is also supposed to purchase a hard disk or external drive. So that is known as hypothesis. But hypothesis again are two types. First one is null hypothesis, another is alternate hypothesis. Null hypothesis means, as I told, buys a computer implies buys a external hard disk. Null hypothesis, contradictory of it. Sorry, alternate hypothesis, contradictory to this. So we have to prove. That is complex part, again we have to go. Just I am giving the fundamental concept of this, idea about this. So after hypothesis formation, then we have to go for the data collection. We frame a rule, then we have to collect the data for that particular attribute. After collection of the data, then data exploration and preparation. The data we have collected that may not be useful for our computation purposes, that may contain some of the impurities, that may contain some of the null values, that may contain some of the outliers. So the data we collect from any of the repository or any of the real-time collection, that cannot be directly used for computation purposes. That need to be cleaned, that need to be pre-processed, that need to be normalized. After that we can able to use that one to get the proper output. So next one is model building. After that we have to develop a model, right? So I shall showcase you the model. Just I am giving some of the fundamental concept of this, how we will step up for a data analytics model. Next one is after model development, then we have to go for the testing. After testing, again we have to validate whether our model is working properly or not. Because we will train with some of the existing data, but whenever some unseen data will be given to the model, whether it is giving the proper decision or not, that is also one of the challenging tasks. Clear? So this is one of the model I have explained. So we have a problem. That means whatever I have step by step written, that is given just in a graphical way. Suppose whenever a problem is coming to our mind, then we are analyzing, then we are giving to any of the system, because we have developed the system through the help of IT. So this system is given the input with the data set along with some of the business intelligence or tools or models. That business intelligence may be data mining techniques, it may be artificial intelligence, it may be soft computing, or it may be any of the machine learning models, right? So with the help of that particular techniques, we are developing a model, and the model is being developed in the system. So after that, we are giving the input to the model to predict for our decision making purposes. Next slide. So these are the basic instances I have given you. 3 instances. First one is Netflix, Amazon, and Tesla. So nowadays, all the system manufacturing industries, they are also using the data analytics for automated manufacturing in order to decrease the number of users or decrease the number of employees. So similarly, all of you are acquainted with the Amazon services, right? So how they are maintaining the inventory, how they are tracking the product delivery, how they are maintaining all the financial transaction of a customer. So all are automated system, right? So all these 3 bigger companies, they are using the data science or data analytics for their business purposes. So building blocks of data analytics, if you go for the scientific, as I told you, it's a technical concept. So these are the basic techniques or basic science we are using for developing a data analytics model. First one is statistics. So under statistics, we are using basic process, mean, deviation, standard deviation, variance, covariance, all these things we are using for data analytics. But gradually, some cases statistics gives better result, but in order to cope with the random data, right? So we are using some advanced technique like machine learning, data mining techniques we are using. In data mining techniques, we are using basically for classification purposes, clustering purposes, outlier detection. And we are also using some artificial intelligence and machine learning techniques for same classification purposes or clustering purposes. And the last one is the computational intelligence techniques, also some simply we can say the soft computing approaches also we are using, that is artificial neural network, convolutional neural network, and deep neural network, that are also being used for decision making, because we have to develop a adaptive network. We have to train the network with some of the models. Whenever we are testing, it may not be tested with a similar type of data, it may be different type of data. So our models should able to validate with the unseen data or unusual data. So that's why we are using that type of techniques. Then how the data mining is integrating with the data analytics part. So data mining, all of you know that it's a process of discovering useful patterns. Data mining is a process of discovering useful patterns or knowledge discovery. So basically, we are using 4 to 5 concepts as I discussed in the previous slide. Classification and prediction for focused hiring. What type of students we need to deploy for a specific work. So we have to analyze their career, experience, all these things, their salary status, clear? So next one is the cluster analysis, market segmentation as I discussed for supermarket point of view. Outlier analysis, fraud detection. Next one is association analysis, market basket analysis. What type of products should be associated in a single cluster. Next one is evaluation analysis, that is forecasting of stock market. The common example you might have experienced. So these are the basic applications of data mining in data analytics. So data analytics, I am coming to the common example. Data analytics helps the business and organization to make better decision by leveraging, by revealing information that would be otherwise been hidden. So with the help of data analytics, we can able to see some of these significant features. We can increase our vision. So what thing is present in the data that we have collected. So meaningful insight about the trends, then correlations and patterns that exist within the big data can be difficult to extract without vast computing power. So we have already discussed data, but the topic is big data. There is not much more differences. Whenever the data size is very high, data is very complex, then we are saying it's big data. There is no much differences, right? So data analytics is changing the way we experience and provide and receive the healthcare. It provides are using data more frequently than ever before to achieve early detection of disease. So we are using the data analytics for healthcare system for basically two purposes: for early detection of the disease. Second one is drug discovery, which is also one part of business process, right? So data is being sourced through the electronic health record, medication refill records, insurance reports, genomics, telemedicine. So these are the basic way on which we are collecting the data. So data analytics in healthcare, because I have to focus on this particular part. So gradually I explain from where we are collecting the data. So diseases are now the significant leading cause of death. So to assist health practitioners, methods such as machine learning, artificial intelligence and soft computing approaches can find sophisticated patterns in medical data and have the potential to improve the medical care. So we are now using different type of AI and machine learning techniques for prediction of the particular disease by analyzing the previous history of a particular patient or a customer. It may be the previous history, it may be the real-time history. So I shall be showcasing you in two different instances where we have the existing data, how we are taking the decision. We are another system, we are collecting the real-time data and how we are making the decisions. So next slide. So these are the basic issues. So data analytics is some of the issues, some of the use of data analytics in the healthcare domain: extraction of useful meaning out of the data, reduce the unnecessary cost. That means how we can reduce the cost by data analytics part? We don't have any provision of storing the data for a long duration of time. We cannot store our data for, suppose we are accessing the real-time data through any of these smartphones or smart watch or any of the smart component. So where it will be stored? Because the data will be collected within an interval of time. It may be 1 minute or 1 second or 1 hour. So how it will be stored? Where it will be stored? So we have to make a provision so that we can reduce the cost. Rapid translation of knowledge. So how the data can be analyzed, how it can give a feedback that your temperature is more than 100 degree or your heartbeat is increasing. How will automatically get an alert message from your smartwatch or smartphone, right? Second one is increase value. Next one is reduction of the burden of data. So we don't have to take head for where the data will be stored, who will be synchronize the data, who will be take care of the backup of the data. We don't have to take care of those things. Next one is disease prevention. So how can we get an alert message so that we can take the necessary aid from any of the abnormal situations. So next one is reduction of the time taken by the manual computation. Of course, if you go for the manual computation process, it will usually take more time. But using the help of data analytics or by using some of the recent information and communication technology, we can reduce the time itself. Increase the patient engagement in the outsearch. And next one is improve the quality of service. So one good example I am giving, how many of you have visited recently Unit 6 hospital, Capital Hospital? None of you? Okay. So if you go, you can see all the beds of each department has translated to small ICU bed. Because they have implemented DAISY bed. That bed is known as DAISY bed. That bed is inserted with a sensor pad. That sensor pad will be in the bed itself. The patient will be there, right? And a machine is deployed in the with each of the patient. A machine is deployed. Already it is existing. Clear? So the sensors will acquire the body parameters as per the specification. It may acquire the blood pressure. It may acquire the pulse rate. It may acquire the temperature. It will acquire these parameters from the patient and it will transmit to the machine associated with the bed. After that, a Geo fiber is a Wi-Fi connectivity is given. From the Wi-Fi connectivity, it will send to the medical server. So by this particular mechanism, what we do, there is no requirement. The nurses will come within an interval of time to get the record of the body parameter of a particular patient. There is no requirement. So he or she will sit in the chamber, right? And they have to just monitor the system of each individual patient assigned to them. So whenever there will be, because they are fixing a particular range of the particular parameter. Suppose temperature, whenever it will exceed more than 100, again a abnormal message will be delivered to the nurses or caretakers. Whenever the blood pressure similarly range will exceed, then automatically it will give a alert message. So automatically when the nurses or the caretakers will observe the differences, then immediately they come to the respective patient and they will take the necessary aid. If there is any emergency, they can also contact it to the doctors. So these are the things already implemented in government hospitals, just to imagine. So which purposes they are doing? They are for data analysis purposes and analyst purposes also. Clear? So this is one of the model we have developed. So this is a predictive analytics. The concept of this particular model is predictive analytics. So initially we have collected the different electronic health records. As I discussed, we can have the real-time data or we can access the information from any of the repository. So after that we create a database of it. After database we need to pre-process because it requires some cleaning process, normalization process, as I discussed some of the steps. After that we are giving to some base level classifiers. So why we are using some classifiers? Because lot of classifiers are there. Go to next 2 slides. Next. You see, these are the different type of classifiers algorithm available as per the machine learning concepts, right? So there are 7 to 8 number of classifiers, but we cannot provide the data to each individual classifier to take a decision making, right? Go back. So in this particular model, what we have done, what new thing we have done, we are training the data with all possible machine learning classifiers. Suppose we have 100 number of data sets. Out of 100 number of data sets, 60 number of data sets are used for training process. 40 number of data sets will be for testing purposes. So we have trained the process with 60 number of data. Then after that, the model, whenever we are testing, we are developing a model. So model automatically learns from the classifiers. Based on the data patterns that we are using, the association between the data patterns and the relation between the data sets. So after that we are developing a meta learner. That means meta learner is our model which is learning from the machine learning models. So it is one of the common example of ensemble learning. How many of you have heard about this word? Because this is one of the upcoming topic, ensemble learning. That means the model itself learned from the machine learning models process. So after that what we have done, after that we have tested this particular meta learner with the rest of the data sets, right? After that it gets disease classification, then result analysis and performance. In order to evaluate the performance of the model, we have used some of the parameters like decision, accuracy of the algorithm, precision, recall. So these are the few of the parameters we have used through which we can evaluate and we can conclude that this particular model is giving better result in comparison to the classical models or other machine learning models. So this is the model that we have implemented, for which we have used the UCI machine learning repository. Hard disk dataset we have used around approximately, that is 5,613 number of data sets. And after that, one of the attributes we have completely eliminated. So 13 number of attributes we have considered. So age, sex, chest pain, these are the different attributes for which we have collected the data sets. These are used for computation purposes. Next. So the first stage, as I discussed, after collection of the data set, we go for the pre-processing. So we have used different methods for pre-processing. Then after that we go for the data visualization, whether it is a discrete data or it's a continuous data or the data is it's a flat data. So analyzing different type of data, then we go for the model building process. The model building process we have already discussed in the previous slide. That means we are training with all possible machine learning models, then we are developing a meta learner. Next. So data pre-processing, as I discussed, we are using the mean median values for replacement of the dealing with the missing values. Suppose at the time of collection, some of the age of the student is not there. Whenever we are collecting 10 student data, one student data is not there. So we are taking the average of it and we are replacing this. But it is not applicable for all cases. Some cases also it affect the accuracy. So similarly, we have used different methods for outlier detection. That means whose data are not applicable for this particular computation purposes data sets. Next one. So after collecting the data, we have visualized the data. That means how the data set look like with respect to different attributes, right? 30 number of attributes. So these are the formula we are using, common formula that we are using for calculating the precision, recall, accuracy, and F1 measure also we are using. We can also construct the ROC curve for that. So these are the different results we have obtained for using this list of algorithms. So we have tested with individual algorithms, as well we have also tested with the meta learner. So next one. So these are the different researchers published different type of machine learning techniques for analysis, data analytics for heart disease prediction, and they have obtained different type of accuracy. And the last one is our proposed stacking ensemble classifier, last one, that gives accuracy of 91.8. So from this particular conclusion that we have used some of the standalone data, the data is present in the database, and we have accessed the data for our computation purposes for decision making, whether this type of data will there, then is there any possibility of heart stroke or not? Yes, that is our only objective. Clear? So next, coming to the next slide, this is one of the important part that we are working on this. In this particular context also we have published one of the pattern, right? So in this case what we usually do, this is a cloud-based system, right? We are using 4 to 5 concepts over there. There will be machine learning, there will be cloud computing, there will be Internet of Things, clear? And there will be also data mining concepts. So in this case, what we usually do, this particular model will fit to different type of patients. It may be ICU patient, it may be a chronic patient, or it may be an outdoor patient. It is applicable for all type of patients. So initially there will be, we have already developed that smartwatch. We have that smartwatch, right? So that smartwatch that we are using, that is not a customized. You can observe, but do you have any provision of storing the body parameters that is accessed per day in a particular place? Do you have any provision? No. So we have used this particular smartwatch that will be frequently collecting your body parameters, right? After that, that will send the body parameter to a particular storage. As the data generated by the sensor devices are very large, very complex. So we use cloud as an alternate source for storing the data for large duration of time, because it can be helpful for storage, analysis and decision making as well. So after that, storing the cloud server, then we have given some of the threshold values. As I told, for temperature, it should be, if it is more than 100 degree, then alert message will be given. Similarly, for blood pressure and other parameters, we have given some of the threshold values. So whenever the body parameter will exceed the threshold value, then that can be considered as an abnormal situation, and accordingly a message alert will be given. We have to also develop a web portal for this. So after data analysis, then we are going for the decision making. Data analysis will be done by the machine learning techniques. After collection of the data, it will be pre-processed, then it will, that means it will go on 24/7. It will go on executing the system. Whenever any abnormalities will be detected, then automatically it will give a alert message. So next. This is just the extension of this particular model. Here we are just converted from cloud computing to edge computing, because as we are using more a pulse sensor, another is temperature sensor. Two type of sensors I have demonstrated over here. Okay, next slide. So this is the test bed. You can see the temperature 97 degree and blood pressure 125 degree. We have developed a test bed. Okay. So initially we have used this particular test bed. This test bed do not have its own Wi-Fi module. So data may not be stored by the sensor devices because they are a battery power and very low memory. So after testing this model, it has certain limitations. It can able to also trace the body parameters. So after that, next slide. After that, we implement this model. This model has its own Wi-Fi module so that it can accuse the data and it can itself transfer the data to a particular base station where we can store the data permanently for a long duration of time. So after that, this model has certain advantages. So after that, we have also simulated this particular by using 10 number of students only. We have not developed, we cannot make it more scalable. So 10 now we have tested with this 10 number of students with this type of sensor devices. Next. After that, we can also integrate it, we can directly create a software through which we can able to access the parameters. After storing the parameters, this will be like this, and it can be directly imported to a Excel file, right? So after that, we can also able to see with the help of different type of graphs, what type of, whether any abnormality is there or any type of, whether it is flat or not. Next. So these are the different type of records we are getting as per the date of a particular patient. Next. So we have chosen cloud as the alternative for huge storage, high-end processing, and online analysis and decision making. Because whenever we are considering about the medical server, so you just imagine how many number of patients are there and how many number of parameters we are tracking for each patient per fraction of time. So it will be very big data. So a very large volume of data. So we cannot store the large volume data with a small server or a server that will be only dedicated for that purposes. So in order to overcome the installation cost, purchase cost, maintenance cost, we are hiring the cloud as alternative service for this. So this is the way how we are integrating the cloud with the real-time data. So initially the patients with different type of sensor. It not necessary that it should be always a smartwatch. It can be a smart jacket where the sensors will be deployed, or it can be a smart shoe deployed with different type of sensors that can accuse your body parameters. So after that, that can be integrated with the smartphones. Through the smartphone, it can send the data to a particular base station. So from the base station, it can go to cloud server. In cloud server, we have installed our machine learning techniques where it will be executing per 24/7. Whenever any abnormality is detected as per the threshold value, then automatically alert message will be given to caretakers, doctors, and the patients as well, right? If the doctor is out of station, he can able to log in through the smartphone, right? Because he is given with the credential, he can able to see who are the registered patients under him. After that, he can able to see the previous history also, because it is quite difficult for a patient to store all the medical records, right, for 10 years back. So if we have this type of system, then automatically it can be detected by the either patient or by the doctor. Doctor can able to visualize what is the previous data. So he can analyze the previous data of that particular patient, or what are the medicines suggested earlier. So he can have an analysis online. Even if he is not physically present in the hospital, he can have a analysis and he can give a decision. After giving a decision, automatically the decision message will be delivered to the mailbox or message box of the patient as well as the caretaker, based on the category of patient. So these are the different parameters that we have used the ThinkSpeak for monitoring the body parameters. Next one, this is the portal that we have developed for healthcare system, because whenever we will get alert message, ultimately we have to log into the system. So there will be patient, there are 4 to 5 databases we have considered for patient. One is patient, doctor, caretakers, then next one is lab assistants, another one is there, ambulance services, right? So 5 different tables we have considered. So similarly, we have developed this particular table, so where the doctor can log in and he can able to see what are the data available for that particular patient for any type of decision making purposes, right? So next one, there are different type of logins. Patient login, doctor can able to see who are the patients, under how many years he is getting under this treatment, what are the previous history. So all these type of things can be able to visualize this. And these are the sample we have shown whenever a doctor is giving some prescriptions. He is out of station, he is giving some prescription. So which format it will be delivered to the patient. He can able to see that one and he can take a proper decision. Next. So in this is all about the data that we are, this is all about data analysis. But gradually what we are doing for this purposes, in this, apart from this decision making, it can be helpful for data analytics also. That means it is accessing the real time heart rate of a particular patient or blood pressure of a patient. So by observing that particular patient, he can able or she can able to analyze whether the particular patient is going to affected any cardiovascular diseases or not in future after 2 years. So that means it is one type of alert message for that particular patient for future. So data analytics in this particular concept or in this particular domain can be helpful for both analytics part as well as analysis part, right? So in this particular presentation, I demonstrated you two different concepts. That means how we are analyzing the data, how we are collecting the data, how we are pre-processing the data, and how we are using this particular data for different, using different type of machine learning techniques or data mining techniques for different type of purposes. So similarly, this can be used for any type of business purposes like your sales forecasting, how to optimize the employees, how to increase the sale, how to control the inventory. So it can be applicable for many business segments, right? As I explained, Tesla is using, they have completely automated all segments from manufacturing to sales to inventory management, all these things. So similarly, nowadays aircrafts, they are also using data analytics for prediction. What type of purposes? That means different type of sensors are associated with different aircraft components. That sensors are responsible for accessing the normal behavior of the particular component. If some of the component is behaving abnormally, that means automatically the aircraft manager is getting some information so that he will purchase or he will procure that particular product in backup purposes. Whenever there will be any problem, then he will give the replacement of that. Are you getting what I mean to say? So these are the techniques. Data analytics is being used for all segments. It is not restricted to only any of the business process. So these are the some of the selected references. Okay. Any queries? No queries? So all of you got it? Okay, thank you.
Thank you, Subhashi sir, for engaging the audience in this session and while conveying the process of data mining and data analysis very easily. Now it is, I would like to request Professor Dr. Samarjit Kar sir to take up the dais for the knowledge transfer session. Sir, please.
So good afternoon to all of you. So first of all, I convey my sincere thanks to the organizer for giving me this opportunity to share my knowledge with you. I'm really very happy to be here today. So my today's talk actually on data analytics, machine learning and optimization. Why I choose this topic? Because I belongs to the mathematics department and my research work is mostly based on optimization techniques. So how they are related and why optimization is important in data data analytics and machine learning. So already my previous speaker gave some basic ideas of data analytics. I think you have some knowledge. But the importantly, why data analytics is important and what are the main challenges here and why the optimization techniques are most important for data analytics. So I think already this is not working? Yeah. So this is the overview. So the first part of this lecture, that part already covered by my previous speaker, because what are the main challenges in data analytics and why machine learning is important for data analytics. So actually this part already over. So what is data and what is big data and how big it is, what are the main challenges, that is already covered. So I just skip it. So obviously the big data is basically, it's a, the much excitement, obviously it's a hype around the big data, but importantly how big it is. So obviously there are several applications that the previous speaker already. So if we consider the size of the data, so that means it's kilobyte, megabyte, gigabyte and so on. So kilobyte is 2 to the power 10, then 2 to the power 20, 2 to the power 30 and so on. If we consider the data sets, say in the previous slide you just look, so New York Stock Exchange generate about 1 terabyte of the data per day. So if we consider several examples, say like San Geneva, they produce around 25 petabyte data per day. If we consider the Google data set, so they around 100 petabyte data set per day and so on. So obviously the major challenges in data analytics is because the data comes maybe from different server, different corners, so different patterns. So there may be some are unstructured data, some are structured data. So what are the challenges here? So how to frame all those different types of data into structured data first. So that means what type of data mining techniques have you used to transform it into the structured data. So then the second part is obviously how to store those data and how to arrange those data in a particular form to solve the problem. And finally, how to analyze it. So that is the major challenges. So, okay. So there are several. Okay. So there are several examples of data analytics like business analytics, risk analytics, fraud analytics, health analytics, and so on. Sorry. Okay. So now what is machine learning? So because already data analytics part, my previous speaker already gave some ideas. So machine learning is basically learn from the data and to make prediction about the similarities or maybe the other data which are similar to that. So obviously it is a very interdisciplinary subject. Several areas like linear algebra, statistics, some mathematical techniques as well as some computer science based techniques are required. So optimization is one of the important tool to handle such type of prediction using machine learning. So it is also useful for turning the knowledge into decision. So data analytics can be divided into 3 groups. It may be descriptive analytics, it may be predictive analytics, or it may be prescriptive analytics. So that in descriptive analytics is basically what has happened. So you have the data, so how to summarize or condense data to extract the patterns. So obviously there are some techniques like data aggregation, data mining, so for determining the pattern. Because that data set is already with you and it may be structured data. So on the other hand, for the predictive analysis, what might happen, that means how to predict for the new data sets. So obviously for that, we extract the models from the data and to be used for the future prediction. So that's why it is predictive analytics. And the major challenges is there for the perspective analytics. So what should we do in future? So that means predictions to recommend the best course of action moving forward. So obviously for that, optimization and recommendation, because my main topic is basically the optimization, how optimization is used for solving different types of machine learning problem. So that's why this prescriptive part, that means prescriptive analysis for data analytics, is most important nowadays. So what is machine learning? I think Sarah has already told you the previous thing. So obviously it is a branch of artificial intelligence, and it is designed to develop of algorithms that allows computer to evolve the behaviors of the empirical data. So obviously it is there is a difference between the general computing or normal computing and machine learning. In normal computing, you have some data set, you design an algorithm, and accordingly you can generate the output. But on the other hand, in machine learning, you have the input and output. There is so your target is to determine the input-output relationship from the data set, and you can predict the future. So obviously, machine learning is the study of algorithm, improve their performances with some task, with experience, and optimize performance criteria using example, data, or past experience. So obviously, there is a role of statistics and role of optimization, as well as the computer scientists. So role of statistics is inference from the sample. That means you can, from the inference of the sample, you can design some function. By using that function, you can optimize the error or other things. The form and extend and any initial background knowledge, whether you have the background knowledge of your, sometimes maybe some some company wishes to launch some new product. So obviously, they can consider the data set, yes, from the previous type of, from the similar type of products, and they can learn something, and accordingly they can generate a new, they can generate the function, and they can predict the things. So basically, here there are two important factors. One is modeling, and another is optimization. So that means how to model according to your data set, how to design your model, and then optimization. So that means to develop your algorithm, the main success of machine learning systems depends on the algorithm. So that means how to design your algorithm. So if the algorithm is good, so obviously you can predict much more better way. Algorithm control the search to find and build the knowledge structure. So that means only you have the data. So from the data you can generate some knowledge, and accordingly you can design the model so that you can predict for future. The learning algorithm should extract useful information from the training example. So, okay. So as a whole, machine learning can be divided into three groups. One is supervised learning, another is unsupervised learning, and reinforcement learning. Sarah has already told you. So in supervised learning, obviously the data are labeled, and there is a direct feedback. That means there is a input output, direct input output relationship, and obviously the main target is predict the outcome for the new data set. And for the case of unsupervised learning, there is no label. That means there is no target, but from the knowledge you can design some algorithm, and you can classify the, or maybe they are cluster the data. And for the case of reinforcement learning, this is different types of learning where it depends on a decision process. Obviously there is an external agent. That external agent sometimes guide you. So if you are in the right way, so in that there is a reward system. If you are in the wrong way, then there is a penalty. So obviously it's a series of action where one external agent can help you. Okay, so now little bit of mathematical part, because the optimization is one of the key tool or one of the important technique for machine learning. So how we can design a mathematical model for machine learning problem. So obviously the first step is collected raw data. So it may be any type of data, it may be stock market data, it may be image data, maybe any other type of data. So that first step, you should collect the raw data. And the second step, pre-processing. So how pre-process? So maybe, say if we consider some image data, so only one face of image, one face per image is required. Face is in the center and assign the level of each image in similar way. That means you may consider, say, different features like the distance from the nose to eyeball, and maybe different features you may consider. So then feature extraction. So obviously they reduce the raw data to capture elements relevant to the learning task. So that means maybe there are some noises are there, some features are maybe redundant. So that means you have to process all those data which are redundant data that can be eliminated. Some noise are there that also be eliminated or maybe replaced by some other data and so on. So the next part is very important. Generate training data. That means from that whole data set you should consider say 70% or 80% of data as a training data and other is for testing. So obviously how that data mathematically represent? So that is represented by, I'm sorry. Okay, thank you. So that is represented by xi, yi, that means this is xi, yi represent the training sample where xi, it may be any dimension, it may be, there are p different features are there. So that means xi1, xi2 and xip transpose, this is a vector, it's a vector form, this is called feature vector, and yi is the level of the ith sample. So then the most importantly, we should design the loss function because your yi is basically the predicted features for the ith sample xi. So what is your loss function? So yi is basically your actual level value and yi bar is your predicted level value. So here we consider the mean square error. So mean square error is basically your loss function here 1 by n mod of yi minus yi cap. So learn the model such over a collection of candidate models and choose with the smallest loss. So obviously your target is, so how to minimize this loss. So obviously the characterize the generalization of error is the next topic. So mathematically a data set for analysis involve the optimization. Typically this is in the form of this, where xi's are the feature vectors or attributes and yi's are the levels or observation or responses. And here the main thing is how to, for the analysis part, we have to find a prediction function that is maybe represented as h, so such that h of xj is approximately equal to yj. So by learning how we design this function h, that is the most important part here. Say for example here your main idea is, so you can identify the cat. So obviously for example x belongs to capital X. So you have the data samples which is represented by x cross y. X is the examples and y with the corresponding level. So now for a new x, how to level it? So that means we are designing a function, sometimes it is called magic function. So h, that is mapping from x to y such that h hat x equal to y for all x, y belongs to D. So this is, so how we can design the h hat. So obviously the process of finding h called learning or training, where yi's are the reals and has a regression, it may be a regression problem. So y may be any real value, y may take some real value in some interval or maybe some discrete value. So accordingly we can design the corresponding model. So if yj's are real and one has a regression problem, then yj's, if yj's are finite, that means it may be discrete, so it is called classification. So if m equal to 2, that means there is only 2 classes, so that's why it is called binary classification. The levels may be null, so that means there is no leveling, so in that case we consider it is an unsupervised learning. So here the main thing is data is assumed to be clean for optimization, but still xj yj could be noisy or corrupted. So some xj's yj's could be missing, so data could be arrived in streaming fashion, so that in that case H must be learned from online. So that means H has to be robust to change according to your data pattern or according to a data set. So obviously such data analysis is often referred to as machine learning or data mining. So it may be predicted or supervised learning or maybe unsupervised learning when the levels is null. Okay. So here H is used to make prediction about the future data. So obviously our target is to determine this function H, but it could also be used for feature selection when one has to learn what small fraction of x's is reliable to predict the level of yi. So obviously this H can be parameterized by some parameter w, so that means we may write hw as a h of x and w. So where this hxiw is approximately equal to yj with the known levels j equal to 1 to n. And how much you are correcting this h function from your training data set, so that means how correct or accurate, so that can be quantified by a function that is basically known as the loss function. So this is the general representation is L of x, y and w. So here our target is to minimize this loss function, that is L of summation of j equal to 1 to n. That means according to all the features we have to all the levels, we can minimize our loss. Say for example here how to design this loss function. Say suppose if we consider a simple linear regression model. So obviously in linear regression it may be represented, it may be one dimensional, that means simple linear regression is y equal to mx plus b, or it may be multiple linear regression, that is w1x plus w2y and w3y. So this w is basically a vector w1, w2, w3. So here this dependent variable y has a linear relationship between the independent variables x, and this y value is roughly, we assume this y value is roughly normally distributed. That means here we initially assume they are identically distributed and normally distributed. So it is basically the symmetric or unimodal function. Say for example here if we consider the sales prediction, that maybe depends on the company's advertisement spent on radio, different medias like radio, TV and newspaper. So obviously the sales volume can be represented by a linear function, that is w1 into radio, w2 into TV and w3 into news. So here we consider this root mean square error. So this root mean square error is represented by this, is very easy, 1 by n sum of I equal to 1 to n yi minus this. So there are many approaches to minimize this loss function. The most easiest way we can minimize this loss function by considering this gradient descent approach. That means we just considering the first derivative with respect to the model parameters. So here m and b are the model parameters. So we can determine this f dash with respect to m and b. So that is del f by del m and del f by del b, and it is easy mathematical form. So that means if we represent it graphically, so because this we are minimizing this cost or loss function with respect to the parameter w. So here this is a unimodal function. So how we can, using this gradient descent approach, we can minimize this loss. So obviously there is an important factor that is known as this learning rate. The size of this step is called the learning rate. I will maybe mathematically represent this. So another approach, so that is logistic regression. So though it is called regression, but basically it is used for classification. So why this logistic, why it is called logistic? Because here, we have used a logistic function. So logistic function is basically log of x minus 1 by x. So if we plot this log function, so the graph looks like this S function, the S type. So here basically we are using the inverse of this logistic function. So if we make the inverse of this function, so obviously because this function is x by 1 minus x, so obviously between any value of x is generally x is between 0 and 1. So obviously if we consider the inverse function of this, the inverse function looks like this. And how actually this logistic regression works? So by the previous example you just look, similar example you just look. So if we consider there are some students are there, so there is a linear relationship between whether the student is passed or failed, and Z is function of W0 plus W1 is number of studies, and this is number of slept. So some simple data sets are given here. So how we can represent is as a linear regression, binary logistic regression model. So obviously you just look, if we consider it's two different classes, either is passed or failed, that is represented by 1 and 0. So P of class 1, this is 1 by to the power minus Z. So Z is this function. So if we substitute those values and learn this model with respect to this model parameter W0, W1 and W2, so you can easily classify these into two groups. How? Say suppose for a particular value of number of hours studies and number of hours slept, you determine the value of Z, and by determining this value of Z here, if the value, maybe we can represent it as a probability value. If output is probability that y equal to 1 given x, that means if output is greater than 0.5, represent y equal to 1, and if the value of y is less than 0.5, it represent 0. So that means by using this function, because this functional value always lies between 0 and 1, so that value is greater than 0.5, it represent one class. If it is less than 0.5, it represent other class. So accordingly we can plot those data and we can classify those data into two different groups. So that's why it is called logistic regression. So our main objective is how to minimize this loss function. For this loss function, people have used different functional representation. It may be mean square error function, sometimes maybe entropy functions and other functions people have used. So sometimes people may use this entropy function which is represented by this form. But here the important thing is, if y is 1, your prediction goes to 0. Because in logistic regression, this is very important. Your actual value you are getting 1, but your actual value is 1, but your prediction goes to 0. You are penalized heavily. And conversely, if y is 0 and your model is 1, so you are penalized infinity. So that means you are considering this function in such a way that there is a balance between these two. Okay. So in general, when we consider the data set, the most important part is how to differentiate the data for training, testing and validation. So for training, maybe if we consider say 80% data for training, 10% data for testing and 18% for validation. So train means data is used to train your model, and validation means data that model has not seen yet. That means other 10% data for parameter tuning. So because our most important thing is this parameter W1, W0, W1, W2 and those model parameters. So how to tune those model parameter to optimize performance. And finally the test data sets are used that again they are not seen this data set, but this data is used for any part of computation. So that means the final performance matrix are reported on this data. So what is performance matrices, I am coming. But when we deal with such cases, the two things is very important. One is underfitting and overfitting. So why overfitting and underfitting is important for this concept. So what is the definition of overfitting? So overfitting means Your training data maybe give a very good result, but testing data is not give you that good result. So that means there is a difference between training data and testing data. So then it is called overfitting. On the other hand, what is underfitting? Both training and testing data give you a not that good amount of result. So then it is called underfitting. So conceptually, it is very simple. You just look, say suppose your data pattern looks like this. And if we design a function which passes through all the points, so obviously here for this representation, you just look, this is highly nonlinear. But on the other hand, for this type of data set, if we consider say simple linear fitting, so obviously it is underfitting, because here both training and testing sample data sets, your error is more. But for this particular case, obviously there is a balance, so that's why it is a good model for your data set. So that means somehow for the case of overfitting, you have high variance. For the case of underfitting, you have high bias. So obviously to tackle with this overfitting and underfitting, so you required, there is a balance between bias and variance. So conceptually, how to represent the bias and variance mathematically. So say suppose your model is y equal to fx, and there is an error that is epsilon. So initially we assume the mean of this error is 0, and there is a low variance, that is sigma square. So mathematically we can represent this error function. That means we are basically determine the expected value of this error y minus fx0 square subject to x equal to x0. So this conditional estimation function is important here. And if we mathematically represent it, there are 3 terms. The first term is called variance, and second term is called bias, and third term is obviously the noise. So if n increases, interestingly you just look from this mathematical form, if n increases, the variance decreases, but bias increases. So that means there is a conflicting nature between bias and variance. So obviously our main target is there is a balance, there should be a balance between bias and variance. So graphically we can represent it, because here maybe x-axis represents the model complexity and y-axis represents the error. So that means if error is less, obviously the model complexity is high. On the other hand, if model complexity is high, the error is less. So obviously there is a balance between these two. So obviously the bias curves looks like this, and variance curves looks like this. So there is a compromise model, so that gives you the optimal complexity as well as optimal error. So mathematically here we can use this regression model. So how we mathematically determine the corresponding RSS. So the simple things is given here. So the overall this process is called regularization. So by some regularization process, we can minimize the loss. So here there are 2 types of regularization is important. One is lasso and logistic regression. So here basically in this loss function, you just look, say why it is important. Say you are training, your training is so good, maybe your loss or error is 0. So in that case, so loss is 0 for your training means maybe it is overfitting. So how we can consider that overfitting? By using some function that is basically represented, this part is basically your loss function, and this is another, this is basically called the regularizer term. So this is mod of norm of w square. So w is basically your model parameter. So that means we can design this function in such a way that, so for any training, your loss functions not goes to 0. So similarly on the other hand, maybe known as lasso. So here it is that there is a linear term, this is lambda norm of w. So how mathematically these 2 things are work, you just look. So if we consider this L2 regularization, so mathematically this is your beta 1, beta 2, these 2 are the model parameters. So this is the concept. So we are optimizing those model parameters beta, and these functions is basically cut it here. So that means only the case of L1 regularization, maybe some features are eliminated, because you just look, beta 1, beta 2, this function cut at a point where beta 1 is 0 and beta 2 not equal to 0. On the other hand, here this is your error area, error zone, and you are designing this function beta in such a way that it touches the area at some point where beta 1, beta 2 not goes to 0. So sometimes maybe we can use this L2 regularization. Mostly people are use this L2 regularization. This is much better than L1, but L1 is also important when we want to reduce some features. So after the model fitting, so how to check whether your model is better than the other model? So obviously there are some performance matrices. So how that performance matrices are mostly people have used? There are different performance matrices are there. So here we are using some term that is true positive, false negative, true negative. So this is very simple concepts. Here the number of observation that the model is correctly predicted, number of observation the model is incorrectly predicts that positive classes, and so on. So accordingly, there are several performance matrices can be designed. One is accuracy function. This is basically true positive, true negative by true positive, true negative, false positive and false negative. Then precision, recall, F1 score, many performance matrices maybe you can use for, say, for simple example, we are considering a small data set from this website. This is basically for measuring the breast cancer. And here we use 67% data for training purpose and 33% for testing purpose. And by using two different machine learning approaches, one is logistic regression, we can determine the accuracy, as well as we can use another model that is decision tree, by which also we can determine the accuracy for different performance matrices. Okay. So another thing for optimization, you just look, people have used several optimization tools like gradient descent approach, stochastic gradient descent approach, many more approaches are there. So these are basically known as first order mathematical methods for as a optimization tool for machine learning. Similarly, there are few other methods which are basically known as higher order methods. It may be conjugate gradient method and so on. I am not going to the detail of all those mathematical techniques. I just quickly give you the idea of gradient descent approach. So conceptually, here we may consider a set of functions, because there are many functions maybe you can design by your model. So by using that, we may determine your loss function, that is basically represented by W and B, these two parameters, and here we consider the mean square error. So here our target is how determine the goodness of this function. That means how good your prediction function is there. So obviously here we can determine that F star which minimizes this L function. So obviously we should minimize this function L by these two model parameters W and B. So this is basically known as gradient descent approach. So mathematically it can be represented by this. So conceptually you just look, if we consider, say if we plot your loss function in one dimension, so it looks like this. So we initially randomly pick initial value, that is W0, it may be anywhere in this domain, and then compute this del L by this differentiation of this function at W0. So that means whether this tangent is negative value, gives you the negative value, that means it is negative gradient. So if it is negative, so obviously increase the value of W. So that means otherwise if it is positive, decrease the value of W. So in this way we move. So that means this W, now we determine the new W1, that is W0 minus eta del L by del W. So this eta is basically known as learning parameter. This eta is basically known as the learning parameter that we have. So if this eta is negative, so obviously this value of minus eta del L del W at W0, this gives you a positive move towards positive move. So that means this is your W1, and then again, so this is eta is greater than 0 and it is the learning rate. And then compute again at W1 and so on. So W2 is W1 minus eta del W. Accordingly, we can so reach here. But this is not the global minima, so this is a local minima. So obviously we can start here, but your target is to determine the global minima. So obviously we should change the model parameters as well as the learning rate, so we can reach at the global minima. So the gradient descent approach had the following steps. So obviously our target is to optimize the function with respect to W and B. So obviously we randomly pick the initial value of W0 and B0, compute the first order derivatives, then we can use both this learning rule W1 and B1 with respect to this learning rate eta, and we compute again del L del W at W1 and B1, then determine W2 and B2 and so on. So ultimately this is the general form of this gradient descent approach, and we can solve our model to minimize those things. Similarly, for higher dimension, it may be graphically represented by, so slowly we can reach at the global minima. So obviously here our target is whether we can determine all those argument value of this L theta so that we can determine the corresponding result. So this is the thing, I just quickly, okay. So one thing is important, when we consider this learning rate, so how we can change this learning rate? So obviously, set the learning rate eta carefully. If the learning rate is too large, so cost may not decrease after each update. So if the learning rate is too small, training would be too slow. That means we can change this learning parameter eta in this way. That means by using some normalized factor, this Wt plus 1 at the tth iteration. So Wt plus 1 is Wt minus eta W gt, where gt is del C theta t by del W. And accordingly, we can design this eta W. This is eta by sum of I equal to 0 to t gi square. So that means if I increases, your learning rate decreases. So that means initially your learning rate is high. So that means you move little fast. Slowly you can decrease the eta. So by using this simple function, that means by this normalization, we can change the data. So finally, as a nutshell, we may say every machine learning algorithm has three components. Mostly the important part is representation. That means how you represent your data, and then optimization, and finally the evaluation by using some performance matrices. So whether your algorithm, because when you design a new algorithm, so obviously you should compare whether it gives the better performance with respect to the other algorithm. So obviously, so you can evaluate this by using some performance matrices, whether your algorithm is performed better than the previous or existing algorithms. So there are various functional representation of those machine learning modeling. So it may be sometimes we may use some numeric function. It may be linear regression, neural network, support vector machine. Sometimes we may use some symbolic functions. This is decision tree, rules in propositional logic, rules in first order predicate logic, some mathematical concepts are there. Similarly, instant-based function where we use nearest neighbor, case-based learning. And obviously this is very important because when we use some reinforcement learning, these probabilistic approaches are very important. Naive-based classifier, Bayesian network, hidden Markov model, probabilistic context-free grammars, and so on. So these are the new topics. Maybe someone are interested, you can use. So various optimization search techniques are there. It may be gradient-based search. It may be divide and conquer rule. It may be dynamic programming. Nowadays, people are using some evolutionary computation like genetic algorithm, genetic programming, neuroevaluation, and other things. And obviously for evaluation, people have used many performance matrices like accuracy, precision and recall, square error, likelihood, posterior probability, utility function, margin, entropy and so on. And obviously we can divide the machine learning in different ways, maybe understanding domain, prior knowledge and goals. This is basically the basic part for your data collection. This is data mining part, data integration, selection, cleaning, pre-processing. And obviously the learning part is most important, how to design your model and then interpret the result. By using some performance matrices, you can interpret. And obviously there are several recent topics. My previous speaker already told this may be deep learning, convolutional neural network, transfer learning, cognitive computing, interpretable machine learning, multi-objective machine learning concepts are also coming because mathematically it is very powerful. Finally, for the students, so if we really want to learn this subject, maybe data analytics or machine learning, what are the pathway you should follow? So that is important. So obviously first you have to learn about the basic tools which are related to data mining and machine learning like R or Python, any one of those language. Obviously the second step is very important. You have sound knowledge about the basic statistics and mathematics. So that is very important here. Then obviously you should start your basic algorithm like regression and classification because these two are the most basic algorithms. Then obviously some advanced algorithm like ANN, support vector machine, random forest, some ensemble learning process, and then deep learning, convolutional neural learning and others, and finally the reinforcement learning because this is really challenging nowadays. So these are the pathway for this. These are some references. Maybe if you are interested, you can go through with that. So thank you all. If you have any questions, maybe you can ask. Any questions? Okay then, thank you. Yeah, sure.
Which function you are using, like in case of x and y as a product, and h of base function is x approaches to y. In that case, what model you are using?
So that is very important. So how to design that function h? Because from the data, from your training, so if your linear model is maybe fit much more well with your data set, so obviously we use that linear functional model. Otherwise some non-linear functional model. So sometimes we may use some probabilistic approach also because not all data are completely, that means certain. So some uncertainties are there. So in that case maybe we can use some probabilistic approach also. So that means from your data, from the learning, so which function, that means which function is much more satisfied with your data. So that is the main thing. So that's why it is called learning, no? So from the learning you can design the function which is most appropriate function for your data set. Okay. So anything else? Okay, thank you. Thank you all.
Thank you so much, Jit sir, for your valuable insights on machine learning and data analytics. Now, finally, it is our privilege to have Professor Dr. Manas Ranjan Patra as the chairman for this technical session. The living legend has experienced more than 34 years of teaching and research in the area of computer science. He was the head of Computer Science Department at Berhampur University and the director of University Computer Center. He holds his doctorate from prestigious Central University of Hyderabad. His key research areas are artificial intelligence, applications of data mining and machine learning, privacy preservation in social networks, service-oriented modeling education. Talking about his international experiences, Dr. Patra has worked in International Institute of Software Technology, Macau, China as a United Nations Fellow, where he pursued in some research in thirst areas of software engineering. He has extensively traveled worldwide for presenting research papers and chair in technical sessions in many international seminars and conferences. Sir, please enlighten us with your precious words. Thank you.
So, good afternoon. So, first of all, thank you so much for inviting me to this seminar. I feel really happy to be one among the students because I love students. But now, I think, I'm sure that now you have started thinking about the lunch. So, I will not take a lot of time between your lunch and the talk that I am supposed to deliver here. And already you heard two speakers this morning. One who dwelt on how data analytics can be used effectively in the domain of healthcare. I don't know how many of you really appreciated that or not. This is a very interesting, very challenging application of data analytics, data mining, and all that technique that we talk about today. And of course, the second talk was, it had a heavy dose of mathematics. And I could see from your faces, you were really struggling. And there are only few questions probably he asked and all. But let me tell you, you just cannot run away from mathematics if you want to really use data analytics. If you want to make your career in data analytics, you just cannot run away from mathematics. You have to do that. But if you have decided not to be in data analytics, then you are free not to worry too much about mathematics. But let me tell you, you have a great career in data analytics. That is going to shape the future of our IT industry. And IT is going to really penetrate into many of the applications which is already there, and the applications that will come up in a very short span of time. And people really felt the beauty of data analytics, data mining, and all the technique that we talk about, at least during the COVID time. People were doing a lot of things to predict what's going to happen, how the disease is going to spread. And when the pharmaceutical, medicines were moved, injections were moved from one country to another country, they were very closely observing the supply chain, and so on and so forth. So just don't worry. But anytime if you want me to stop, you can start clapping so that I'll get a message. The first message could be, you are really interested to hear me, or the message that that's enough, so you stop. So it's just left to you. But let me promise that I'll speak only for 40 minutes or so. But you can always cut me short. Now, keeping the background of this particular seminar in mind, I've just chosen a topic very close to the theme of this conference. Data analytics as an enabler for business intelligence. I use the word business intelligence. I'm sure you know about a person called Prashant Kishore. How many of you know about Prashant Kishore? Any of you know about Prashant Kishore? Let me target the students, right? No? Arey Baba, every time you switch on your TV or read some magazines, people will talk about Prashant Kishore. He's the one who is considered as a very smart business strategist. If you have not heard him before, do a little bit of Google search, you will know about him. Anyway, don't feel passive. Don't feel so, I don't want to see you so serious. Because I'm not going to throw any mathematical formula, I just guarantee you. I'll just show you some pictures and I'll interact with you. Because I know the dynamics of the students. Okay. Now, here's a man who is considered as the very smart political analyst. He can probably tell you who is going to win, what kind of schemes, what kind of strategies the politicians should adopt so that they can win. Whether he is true to his word or not, that's a different story. But at least he has been recognized as a political analyst. Okay, another thing. You might have observed I don't know whether at this time people have seen that. There are some wise men sitting on the roadside. Now those wise men will be sitting with a cage and there is a parrot inside. And many of the students will go to those places and ask, suppose you have written an examination, you'll ask, will I get a first class or not? And that parrot will move here and there, and there will be some crossing here and there, and it will indicate something, and then that wise man will tell, yes, you will get first class. And some of you, not now, after some years, maybe at a later age, I will ask you, I'm going to get married, so is my girl, and I'm going to, so whether she will be the right match for me or not. Even the parrot will tell you, yes, she's the right match or not. I don't know how far it is true. It can be a superstition. But something like that can always happen. I don't know. These days, of course, I don't see, because our time I used to see that. See, what I'm trying to tell you, when I'm trying to predict something, when you are trying to take a decision on something, that doesn't happen from blue. It has to be supported by some strong foundation, either through experiments or through some theoretical things or through hypothesis or whatever. Now, these days, when you predict something without really telling how you have achieved that, people will not take you seriously. Therefore, people will use a lot of graphs, a lot of analytics, based on the experience, based on the data that is given to the people, and then they will give an explanation why they are saying so. I'm sure that many of you knew that Obama, for the first time, he used a huge amount of data analytics when he was winning his election. So the concept of data analytics, the machine learning, the artificial intelligence is not only restricted to the scientific community, but it is really percolated down to the business people, the business, healthcare, and many industries. That is the reason why I said this is going to be the future in the IT industry. Okay. Oh, in the meantime, it has really moved. So I was just trying to ask you a question. Who can really define what is intelligence? Because going back to the Prashant Kishore example, if you ask me who is going to win this election, he will say, okay, party X. Then you ask how? Well, I use my intelligence. I don't know whether he uses intelligence or not, that's a different thing, but he'll say. Who can really define what is intelligence? No, don't try that. It is not necessary, because no book will tell you the correct definition of intelligence. So the way I perceive intelligence can differ from person to person, the domain in which I'm working, the way I look at intelligence, right? The way I understand that. But essentially, it appears an intelligent person will exhibit some behavior. Now from the behavior, probably will guess, okay, he's an intelligent person. So normally you will find kind of an ability to learn out of experience. An intelligent person learns from the experience. He can solve difficult problems using some kind of heuristics, some tricks here and there, using some common sense knowledge, or you can use knowledge to adapt to new situations, right? So these are some of the characteristics of an intelligent person. For example, when I came here and when the talks were going on, I was thinking what I'm going to speak. Because if I show you complex algorithms and the analysis and the graphs and the formula, I can know what would be my condition. So therefore, using my intelligence, bit of intelligence, common sense, always I carry two sets of PPTs. I was just sharing with him. One PPT, if I find some serious people, research scholars and all that, those who are working in that area, I'll use that. Otherwise, for a general audience, those who like to understand the concepts, later on they want to carry forward some conceptual things. So I'll not tell you which PPT I selected. In fact, I selected the one which will give you a kind of a general. So that is probably a bit of intelligence somebody will use to handle situations that arise on the spot, in the real time, right? So that's probably you will use some kind of intelligence to this. Now, just to put things in context, these days people are talking about the autonomous vehicles, driverless cars, things like that. So from that perspective, I was trying to understand what is the role of intelligence. What are the different types of intelligence? See, if I want to have a business insight, if I want to have an insight into the business that I'm doing, things will not be clear to you. Like in the previous speaker, they said, there will be a lot of huge amount of data in terms of gigabyte, in terms of petabytes. Those data will not carry any meaning to you unless you know how to analyze that. So there are some patterns which are hidden inside that, and you should be able to understand. But as human beings, we have our limitations. How much we can understand, how much we can see. For example, some times back, I'm sure that you know about a chess player, Garry Kasparov, he could see some hundreds of steps ahead of that. And that's how they had to, the IBM people, they had to build a machine called Blue Deep, if I remember correctly, Blue Deep, just to defeat that, right? Because these machines could foresee 200 million steps ahead, just to beat the human mind. So the idea is that when you have a huge amount of data, and if you want to make the best use of the data, you must have some insight into data. And that data will really help you to take informed decisions, smart decisions. And that is what we need in a business environment. Now, why I'm showing this example, when you talk about an autonomous vehicle, there are 3 levels of intelligence that you use. The first is the natural intelligence, the human intelligence. The moment you sit down and sit inside the car, you just check whether the brake is working or not, whether steering is moving or not, whether the rear mirror is open or not. There are minimum things that you do. That's your intelligence, because out of your experience, you know, okay, these are the minimum things that I need if I want to drive my car out of my lane. Then once you are comfortable and you are there on the road, then you'll use, these days in the new vehicles that has come, you will try to turn on the self-driving features, where, because I want to just lie down in a relaxed way, like this person, so just look at this person. So he has just left his hand out of the steering wheel, and he's just relaxing, because he has turned on the self-driving feature of the car, so that now the car really maintains the speed, it is on a particular track, and so on and so forth. But this will not continue for a long time again. After a while, you will find that you are trying to change your lane, or you are trying to speed up. Then you have to make sure that when you are changing my lane, no other car is besides me. Or if I'm trying to speed up, I have to make sure that there is no car in front of me. Or when I'm trying to apply my brake, I must say that there is no car that is very close to me. Right? There are few things that I have to do. So therefore, what you have to do is, you will try to switch on the driver assist features, the features that will assist the driver. Because in case of a completely AI-enabled system, you are totally dependent on the input that is given to you. And you are just relaxing, and you are allowing the machines to really move forward. So you will start switching on to the driver assist features like collision detection, just to make sure that there is no other car in close proximity. Or you try to switch on the blind spot avoidance features, because if I'm turning, I don't know, there are some places where you cannot see your back. So those are blind spots, and so on and so forth. So essentially, you cannot really depend on this AI or machine learning, right? Because these days we use these two terms interchangeably. Okay, there are some subtle differences in this forum. It's not necessary that we'll go into that. But artificial intelligence is an umbrella term, which includes many things. Machine learning is one of that, which really gives you the power to analyze the data and get powerful insight from the data, which can be used for decision making, and so on and so forth, in whatever domain that you want to use. So therefore, the last one is termed as the augmented intelligence, where both the human being and the machine will work together, right? So if you are becoming too much dependent on a machine, things like the Bahanagar incident will happen. Of course, there was also a human interest. There's investigation going on. That's a different story. But you cannot be too much dependent on the machine. You need some kind of interpretation coming out of the human being. Now, the next question is, because you need intelligence, now what is the question from where you get your intelligence? What is the source of intelligence? Can somebody try? What is the source of your intelligence? At least one or two. One boy, one girl should respond. What do you think is the source of intelligence? Any of you? Any of you, quickly? Come on, otherwise I have to... please go ahead. What is that? That's the source of intelligence. Okay, internet or people. Internet is fast. That's very important. So that's the source of intelligence. Anything else? See, we learn a lot of things from the internet, but when it comes to apply that, we fail. We don't know how to apply that. Because there is a huge amount of information load. I'm not saying internet is bad, but many times you don't know how to make the best use of the stuff that you get from the internet. Okay, so there could be many answers. Again, I don't want to get into all that. So normally, we get a lot of, in this context, in the context of the seminar today, we get that power to understand our situations from data. Experience is also data, right? Experience is also data. So if I visualize that my experience comes from data, then I must know how to learn from the data. So just the previous speaker explained very interesting learning models. How you train your system, build a model, and then subject that model to the real data so that the model behaves in a predicted manner, right? So you build your model through different types of learning algorithms. I don't know whether you have taken note of that. He listed a huge number of very prominent learning algorithms which are being used to build this kind of learning models. For example, our human mind has learned a lot of things from the data. So the way I behaved some 50 years back, my behavior has changed over a period of time. Because I have learned from data through interactions, by reading books, by listening to people. So over a period of time, you learn things. Similarly, you also train a model to learn things so that the model can be useful when I want to analyze the real data that you present. Now, how accurately the model will behave, that will depend on the quality of the data, right? So there are again a different line, how you enhance the quality of the data through some pre-processing from feature extraction, because you listen many things. You don't use all of them to build a model, right? When I walk on the road, there are many things that I see, but I have a specific attention to certain thing in which I'm interested. So that's again a huge area, that how you prepare your data to build a model using different types of feature reduction, selection techniques, so and so. So anyway, I'm not going through that. You might have seen that. These are the sources from where you get the data, and therefore you have different types of model. Now, considering the importance of data in today's context, so people use a term called drip syndrome. Now, what is this drip syndrome? I think you can just read it for yourself. We are data rich, but information poor. Now, that girl over there, he said, where from you get your knowledge? He said, from internet. But do you think that you have read each and everything from the internet? I'm sure no, it's just not possible, right? Because the data is expanding so fast, you just cannot catch up. And many times you don't know where to search, what to read. So we have a lot of data, but we don't use it properly. So that, we call that as a drip syndrome. We are data rich, but information poor. For example, in our time, there was no photocopying. So if I want to prepare a note, we have to go to the library, take 3 or 4 books, and prepare a note of our own with a pen and paper. If I ask a question now, how many of you have prepared a note during the last 1 month on any topic? Anybody has prepared a note, read 3 books, and made a note of yours? I give you guarantee, none of you. Because you depended on the PPTs given by your teacher, or you try to download from the net. Now you can do that. I'm not saying that's not wrong, but have you gone through that or not? And you see all those PPTs just before the night, the examination, right? So that's the way you do that. So you have a lot of information, you know that information is there, but you don't use it. So that is your drip syndrome, right? If you don't consume the data that is given to you, that's of no use. It's there in the book, it's there in the internet, it's there in some electronic resources. So it's not that I'm saying, or some of the faculty members are saying here, but the World Economic Forum, in their report, they also mentioned that data is the new oil. You know the importance of oil. The Middle East today, why they are so important? Because they are rich in oil. They can really sell oil and make a lot of money out of that. But data has been elevated to that level. So data is being considered as equivalent to oil. That's the new oil. I'm not going to read the rest of them. You can just read for yourself. But if you just have the oil, crude oil, it's of no use. You need to process it, right? That will suit your purpose, right? If it is to be used in an aeroplane, then you have to make an oil for the aviation industry, right? The same oil will not work there. So it has to go through some kind of a transformation so that it can be used for the purpose for which we are interested to use it. So therefore, you need different types of techniques to understand that. And the Turing Award winner, Jim Gray, he also said that data science, which is quite synonymous to data analytics, he said the data is the fourth paradigm. Normally, in the scientific community, we depend on empirical studies. We conduct experiments and you try to understand things. Sometimes we develop theories and see how it can be applied. And sometimes we do a little bit of computation. For example, in computer science, we do simulation and then try to prove something. But now the concept is data-driven. So most of our actions will be driven by the data. So that's why it says the fourth pillar. Now, a little before, we heard about big data. Now, what is this big data? Again, I will not try to define it. In the book, you won't find a clear-cut definition of big data. But essentially, they talk about these 5 V's and somebody added another 2 V's. It is essentially something, it's a huge volume, it changes very fast, its veracity, its value, and so on and so on. So you get this from the book, so I don't have to explain that. But once you have the data, what you can do as a business organization, because here the focus is on business, so what you can do with the data. Like, as I said, if all your contents are there in the book, if you don't read it, if you don't digest it, then it's of no use. So exactly in the same way, if you need to know what exactly you're going to do with the data, probably the data can help you to build organizational knowledge, right? You understand how the business is working, what you are going to supposed to do. You can build data models to understand the relations, right? All the algorithms that were mentioned, those algorithms will enable you to bring a connection between different types of data. How one data item depends on other. How a particular data item can decide certain things, right? Normally, in a very simplified term, we say something called a dependent variable, something called, what is that? Independent variable, right? So, again, don't worry, I'm not going to show you any formula. So you know that the idea is that the data items which will help you to predict something, right? Which will try to extrapolate something. So you try to connect those things. You will be able to predict and you will be able to make strategic decisions. See, you might have observed the Wagoner car, for example, that was there in the market. People didn't like the shape because it looked like a box. But the other day I just saw a new Wagoner car. There has been a lot of changes. Now I was thinking why there was a change. I'm sure that people like me, people like you, might have given their comments because they ask you feedbacks. They would have said that, okay, I don't like the shape. Everything is fine. So it's comfortable to drive and the sitting arrangements, the elevation, everything is fine. But the shape is not good because the backside is like a flat, looks like a bus. Some people might have given that comment. And that was taken seriously by the company. And they have made some changes in the structure of this. And I'm sure that you also have the experience of buying products in Amazon, you know, the sources from where you can buy. Now, every time you buy something, they will also recommend you something. People, those who bought this, they bought that. And sometimes I also marvel how in a shopping mall, why they arrange certain items in a particular way they do that. Why they do not keep a Dettol bottle near bread? Have you seen any shopping mall? They have put a Dettol bottle near, let's say, bread? No. So sometimes I wonder how they have arranged it. So that is where they use a lot of data analytics. They try to understand the behavior of the customer, what the customer would like, what the customer would not like. So based on that, they shape their business, they take decisions, they arrange things in that way. So once again, I'm not going to read all of that, so it's all discussed. But once you have a proper insight into the data, it can be really applied. And it was also mentioned that the data analytics can give you 4 different levels of capabilities. The first one is descriptive analytics, which can explain you what happened. Something has happened. It can explain you what happened. The second one is diagnostic analysis. You'd like to know why it happened. You need some kind of explanation. The diagnostic analysis will really explain you that why it happened that way. And predictive analytics, it will help you what is going to happen in future. It can predict based on the historical data that you have. And you can still go ahead with what is known as a prescriptive analytics, where it will explain you how can you make it happen. So I want to be the top. I want to make a brand in the market. So I have developed my strategy. How I can achieve that? So it's all goal-driven. How I can achieve a particular thing. So it can give you the. Now, as you move to the right in the x-axis, you can see how complex it is. Something has happened. Understanding that is fine. But when you are going to predict and when you are going to achieve some kind of strategy, that business strategy that you have developed, you must know what kind of data you'll use, where you'll use, and how you depend on different models and so on. So the complexity increases as you move in the right, to the right of the x-axis. Now, today, how many of you have heard about this term, business intelligence? I'm sure some of the management students should know that, right? Any of the students have heard about this business intelligence before? No? Okay. You can Google search and you can find out. See, these days you find lot of terms floating in the market, in our market in a sense, in our literatures, right, in books and magazines and so on. So at least you should understand those terms. Because I'm addressing the students, you must have a understanding of those terms, whether you really use it or not, but you should know what is what, because that really helps you. So business intelligence is all about how you can make technology, how you can process a huge amount of data for the benefit of running a business, to have a competitive advantage over your competitors. Because there are a lot of brands which are there in the market, because unless you have an edge over others, people will not come to you, right? There will be a customer churning, they will go to another brand. So you need to use some kind of intelligence, even your business, to be always a leader in the market. Say, for example, in the roadside, you might have gone to different pizza shops or momos, for example. So if you go to, let's say in Bhubaneswar, I'm not sure which place here, but I know that near that world and all, there may be many momo shops, but you tend to go to a particular momo shop always. Why not to others? Right? Because that momo shop knows how to make some changes every day, or he will be playing some music nearby. He knows how to attract you, right? So there may be many options. So unless that shopkeeper is smart enough, he will not be able to attract the customer. The other day customers go to another person. So they have to be very agile. They have to be very up to date. They have to be very smart to always hold on to the customer base. So that's the biggest challenge today. To hold on to the customers is the biggest challenge today. And you cannot do that unless you have the real insight into the business that you're doing. And that comes not from the blue. You cannot see a dream to run a business, but you have to be heavily dependent on the data, and you must have the knowledge about what is happening in your surroundings, who are your competitors, and so on and so forth. So there are three things that normally you do. Strategy, you must have a strategy. You must have a foresightedness, should be able to see how things will happen in days to come, and a logical mind, the reasoning that you have to use in order to analyze what is what, how you should move, and so on and so forth. Now, what is the benefit of this business intelligence, which is heavily dependent on your data analytics? So I will not go through all of them. Many of the things are self-explained. Improved decision making. You can take a better decision if you have the right kind of data, the right kind of model, right kind of strategy, right? Taking decisions, especially in a business pyramid. In your, I'm sure that both the MCA student as well as the MBA student, they know about the MIS pyramid. What you have in the top? The strategic level. What you do in the strategic level? You take strategic decisions. Whereas when you go down the pyramid, they are just busy with the mundane tasks, the routine tasks. But the strategic decisions are taken at the top level. Again, they don't do that in a very crazy manner, but they take a lot of data from the lower level. And based on that, they take a decision. So decision making is very important, which is heavily dependent on the data. Enhance efficiency, better customer understanding, competitive advantage with your competitors, and the risk mitigation. If you can foresee that there is a risk coming, you can be a little careful, and you have to take some corrective measures so that you don't get into that kind of a risk. Now, very quickly, we'll go through two applications of data mining in the area of marketing and also in the area of, let's say, supply chain. So because many of things are already told, I'll move very fast. Data analytics in marketing. Now, marketing is a very tricky job, right? Marketing is a very tricky job. There are some people that are very good at marketing. So for example, many agents would come to you with policies of LIC or HDFC agents and many other mutual funds and so and so. Some agents will be able to successfully motivate you to go for a particular product. And some will meet you a number of times, but they may not be successful. So marketing is a very tricky, strategic, and sometimes people say it's an art to convince a particular person. Yes, it could be art, because as far as your speaking style and everything concerned, it can be art, but there is also some background. So a marketing manager will be successful if he knows, before he meets you, he knows your background. So the way he will try to pitch himself will be always different from if you don't have known a little bit about you. So they do a little bit of research before they come to a particular person. For example, our Prime Minister, he's also a marketing manager. I'm sure there is no political party here, it's okay. So because when he goes to a particular country, so I'm saying in this sense, when he goes to a particular country, he knows what kind of business deal he should have that. It's not that he's just going just like that and attending a function, giving a big lecture and attending a lunch or dinner. It's not like that. There are a lot of things that are happening before one prime minister meets another prime minister, because they need to know each other's deal, where they are good at and what kind of strategy that you build and so on. So marketing is an area where you need to be extensively using a lot of data based on which you will place yourself before your customer. Customer segmentation. See, based on your geographical information, your location, your behavior, and many other traits, your income. So the companies, they always they try to segment the customers. For example, in a small place like, let's say in Barhampur, Cuttack, where you come, so you may not have a shop, a agency fair where you can buy an Audi car, because there may not be many takers in those areas, right? They will try to bring a car which is suitable to this particular place, right? So that's how they can also create a segmentation of customers in order to identify which product will sell best in that area. So that's customer segmentation. Performance tracking. See, you have taken some initiative and you have deployed people to do certain job, but you need to perform, you need to really track them, what they're doing, what is their performance, because you will try to replace them with another person. Either it can be a human resource or it can be a product. If a product is not selling in a particular area, well, you can always try to customize it in a slightly different way and you try to present them. All right? So that's about performance tracking. Customer journey mapping. So many times we visit a site, but we don't buy it, right? We just, like window shopping we used to do long back. Now you just keep on clicking on different places. Let's say Amazon or Flipkart or any site that you're doing. But maybe finally it may not be converted to a real purchase. Somebody can really track it. See, that is what they do in digital marketing, right? They observe your click stream, how you are clicking, what is the order in which you are clicking, how much time you are spending in a particular page, and how frequently you come back to the particular page. So all such information, even when you are clicking on a website, the search engine and the software which is running there is gathering a lot of information. And that is how they'll try to push that particular product. And many times, I just remember, sometimes back, we just wanted to buy a particular product. We in fact didn't buy it. We just saw the product, spent some time, and we moved to another place and so on. And after 3 days, that, the salesman is in front of our house with that particular product. And trying to sell you, sir, this is the product that you have ordered for, and this is the product. I said, we have not ordered for that. How do you know that? And then when you go back, they could get the information from the area in which we are browsing, our browsing history, and probably alerts were sent to the people, those who are in charge, and they are trying to push that particular product because they saw some kind of interest in the customer. So he's the potential customer. If I bring the product, maybe he will buy that. See? So these days, there are a lot of interesting things happening. So for example, just to tell you, when you attain the age of retirement, suddenly you'll find a lot of, when you open the Facebook or Twitter account or whatever, so you will find a lot of advertisements telling you, the financial, analyst will tell you how you should invest your money. See, because they have the information about your date of birth. I don't know, when you are in the age of retirement, you will get that. Very recently I got that, that's why I'm sharing it. One fine morning, the day I retired, after the next day, I saw in the first book, the first item was, what is that called? Financial investment. I mean, somebody was trying to give an advice on financial advice. So I was wondering that all these years I never got this message. How suddenly I got this? So somebody is very smart. He used that date of birth and then try to tell me something probably in which I'm interested. So why I'm giving this example, you can just see how much of data analytics they're doing, how they're analyzing the data and how they're able to collect information from different sources and give you a very customized product or customized information or customized service. And I was reading one article where he said, see, most of the time when the players come to the ground, we expect a lot of things. For example, when Dhoni is there on the ground, we are expecting some blast in that evening. Or even for the football players, like if I remember the Messi, the Maradona, for example. When Maradona was playing his last match, last World Cup, he could not score he could not score. I don't know whether you remember that or not. So he was encircled by the opponents that he was not allowed to score. And today, probably he was encircled and he was not allowed to score. But today, people use a lot of data analysis to find out what is the best position for a particular player. If he gets to that particular position, he will suddenly convert that to a goal. So the opponents will try to stop, never allowed to go to that particular point. So that's kind of analytics, right? Even in the cricket also. So they keep on changing the bowlers. See, they understand the strength of a particular batsman, where he can hit. So they will try to bring, and where he's a little bit weak, so that accordingly they will try to adjust the bowlers. So even in the ground, even in the playground, you see data analytics. That's what I'm telling you, right? So we started with healthcare, many other applications, then all these applications in business, even in the playground, you find the heavy use of data analytics. You have to be really smart, right? Predictive analytics, somebody said. Campaign optimization. Now, especially in the digital marketing area, you try to do campaign through advertisements and many like prompting certain messages on your screen in your Gmail and in your Facebook and so on and so forth. So you can optimize, you can find out what is the best medium through which the campaign can be successful, right? So for example, in order to catch the young people, they will use a different strategy. And they'll use a different other strategy for another age group. Social media analysis, you want to know what people are talking about this particular product, right? It's not that you're just selling, but you also try to overhear what people are talking about this particular product. And how they can know that? When you exchange messages through social media, right? When you exchange messages through the social media, they can get a lot of information from that. And the business can benefit when you get a lot of information from different sources to do that. Customer retention and churn analysis. Little before I was saying, business is so competitive today. If you cannot hold on to, if you are not very smart, it will be very difficult to hold on to your customers. So customers will go for another brand and another market. So to retain the customers and to stop this kind of churning of customers from one product to another product, you need to understand the dynamics of the behavior of the customers, right? What they want, what they do not, and marketing budget allocation. So I just said that which campaign channel will best suit to a particular product. Okay? So again, there can be many examples, not much time, so I'll just skip that. Now, another application where you can see the use of data analytics is a supply chain management, right? Supply chain management is also a very tricky job. It's not that simple because you have to get material from your raw material suppliers. You have to do the manufacturing. Then you have to ship that to a different place, and that will be kept in a warehouse. Then finally move to the customers. It's a very complicated thing. Now, today, supply chain was happening. It's not a new term. It was happening quite for a long time. People have started using another technology called a blockchain technology for supply chain. And they use a concept called smart contracts. Because once there is an agreement between the customer and the supplier, or whosoever is the stakeholder, you must stick to the smart contract, the contract that you have made. Now, if I want to ensure that you adhere to the policies, the terms and conditions of the contract, you must make sure that there is no deviation. There is no deviation from the contracts. Now, in order to make sure that, they use what is known as a blockchain. There will not be any manipulation. Again, I'm not going to that domain, but this is a technology, at least you might have come across this word. Now, this is a technology which will make sure that things happen the way it is planned. It follows the workflow, and whenever you find a deviation, it will send the relevant information to all the stakeholders. So you just cannot put a record and take out the record at your will. Anything that you do, any manipulation that you do, messages will be sent to all the stakeholders. So it is traceable, right? You can just trace what is happening. Now this use of blockchain, again finds a lot of application in the supply chain, also in land record management, and there are many applications. Okay, forget about that application. In supply chain, what happens? So for example, I think that was very much in news when the COVID vaccines were moved from Germany and from UK, I just forgot the names of those companies, when they were transported to different other countries, they were actually monitoring how they are moved from the manufacturing unit to the customers. Because they have to maintain temperature, so that's how they use different sensing technology to maintain the proper temperature so that without any damage to the medicines, the injections, it really reaches the person. Now, if I want to track that, again, there are many tricky things that you have to do. If you ship a lot of things and there are not many takers, so things will deteriorate. I mean, your products will not meet the standard. It will be destroyed by the time it reaches your customers. Now, if you produce more and then you sell it, maybe you don't have space in the warehouse to keep it, right? So there are many issues which surrounds this supply chain. So with the help of the data analytics, in fact, you can really know what is happening, and accordingly you can develop strategies so that the items or the products move in a particular manner. So I was just talking about this. So there are many stakeholders, right? I don't know whether it's visible from that distance or not. There are many stakeholders starting from the raw material suppliers until it reaches the retail customer. Now, at every stage, you need to monitor that. And there are a huge amount of data that it generates. There are many issues. Anyway, it's not much time to describe that. So if I want to monitor that, so we did a little bit of work. One of my students is working on that, using a blockchain for supply chain management, and with the help of a lot of machine learning. And he understands, for example, if you ship a very expensive car to a particular country, now the way the car is used in the particular country will depend on the road condition and many other things. For example, the car that comes from India, you can just know how frequently it can have problems. But if the same car is moving in Japan or Australia where roads are so smooth, so it can have a long life. Now when the car goes, they really monitor they monitor the health of that particular car throughout the lifetime. So, and when there is a problem, after selling the car, if there is a problem and the person goes to a service center, they get all the history. And that history is again given back to the manufacturer so that the manufacturer has some idea how that car is doing well in a particular country, in a particular road condition, right? So there are this kind of tricky things that they may get as a feedback, and that they will use in future to modify their products or take care of those pain points so that the product still is there in the market. So we did a little bit of work on that. Anyway, it may not be visible to you. So this is all about that. So you can also do, in the context of supply chain, you want to forecast what is the demand for a particular product. So accordingly, you manufacture and keep that ready. You also need information about the inventory management, right? So because you need to maintain, you have to really store the products, both the raw materials as well as the finished products, and it has to be properly maintained in the inventory. So you need a lot of information, what is the demand, how much you should get, so that you never say no to your company. For example, in Japanese they use a term called JIT, just-in-time technology. Now what is this just-in-time? Produce whatever is actually required. Don't produce more, don't produce less. If you produce less, many times you have to say no to the customer. You have to cut a sorry figure because the customer is saying that the customer has to wait. But if you produce more, again you have a problem because you have to store it, right? So for example, if you go for a new model, a new car, you won't get it from the market immediately. They'll say, okay, after you book the car after 3 months. So in that case, what happens if Brezza is selling well, people will move from Venue to Brezza. Just I'm giving an example. Because maybe within 15 days you will get the car, right? So these kind of informations are very, very important, very, very crucial when you are running a business because you need a lot of data in order to strategize things. Supply evaluation. So you need to see whether the supplier is really keeping time in terms of quality, right? In terms of deviation in the supply of a particular product. So you may continue with the same supplier or you can change the supplier. You need a lot of information. And if something goes wrong, you just don't leave it like that. You also do what is known as a root cause analysis. Now, in order to do a root cause analysis, in fact, you need huge amount of data. You must have the appropriate technique, appropriate tools to analyze that data to find out why things went wrong, right? For example, in a different context, when that rail accident happened, there are a lot of things that were happening. They're trying to understand why it happened, right? Similarly, if something goes wrong in your business, you have planned something and your plan is not working. You have come out with a wonderful product, but it's not selling in the market. You need to know why it is not selling in the market, right? So again, you are dependent on a lot of data to dwell on that. So transportation optimization, I was saying that you have to schedule your transportation activities. You have to optimize do the route planning and all that. Quality control and the supply chain risk management in case you envisage there is a problem when the items are moved in a road, what are the problems that you may face because of various issues. Sales and operations planning, how do you actually plan for your sales and how you operate to move products from one location to another location. Product lifecycle management, okay. So these are a few things that probably you can know. Now, I think I'll just skip this because in the previous speakers they have already talked about what are the operations that actually essentially you do when you analyze the data. So you collect the data, you do a little bit of pre-processing, clean the data because all the data that you gather may not be useful for you and therefore you do a little bit of pre-processing. Then you need to transform because you get the data from different formats, different sources that may not fit to the tool that you have decided to use, whether you are using a Python as a tool or a MATLAB or a tool or any other tool that you talk about or you have written your own program. So you need to really transform the data in a particular format and where you can do the processing. You can do some exploratory data analysis. You just play around, you increase one parameter, decrease another parameter, adjust certain parameters and find out what is the effect of that, right? So kind of a simulation that you do to understand what is the role of each of the parameters, right? Like for example, you are asking, how do you adjust the value of h, right? So that the system learns much better. So you can really adjust the parameters and you can have a visualization of what is the impact of one value on others. And I think already you discussed there are 3 different types of data. So data visualization is very, very important. So all these tools, they also give you some kind of visualization because the manager working in the top level, he will not look at the formula, right? He will not understand what are the variables. But the visualization tool that you present, that makes sense for the manager who is taking a strategic decision, right? So you have n number of visualization tools. I know that there are students, those who have made a career only on this part, right? Given the data, they can just plot things, present things using different types of dashboards, using different types of visualization tools for a real comprehension of what is happening with the data, right? The 3D graphs and things like that. And again, I'll just skip this. We have talked about machine learning and AI. And probably I'll also skip this. That these are the techniques which people talked about. Because when you have a lot of data, you want to classify things into different categories. You need to find the outliers, for example. Because I can see there are most of you are wearing your blazers, for example. But I can still see there are some students, those are not wearing their blazers. So they are outliers from this group, for example, right? So you can understand, we don't want to get rid of the outliers. We don't want to get rid of the outliers because they also provide information. Maybe if somebody is not wearing a blazer, that really prompts me to ask, why are you not wearing a blazer? We will say, okay, I was coming and it was raining and it's got drenched. Or the blazer that the institute gave me when I joined, now it doesn't fit me because I have eaten much and I'm fat, it doesn't fit me. So then next time the institute will give you an oversized blazer so that at least during 2 years, even if you eat much, you don't really become flat and really fat and it really works. So what I'm saying is, even finding the outliers, which doesn't fit into a classification model, they also provide a lot of information. Because that can really guide you in a particular thing. Because you have expected a particular thing to happen. You have classified something, but there are certain items that doesn't fall into that. So that can also give an insight. See, all these techniques that you're talking about, I just listed few. I didn't mention the real algorithm, but overall the techniques that you have discussed, all these techniques are in place to understand the nature of the data and to understand the patterns which are implicit in the data, which is not otherwise visible to a human person. As human beings, we are very smart, we know how to analyze the data, but the computational power, the consistency which we can do that, a machine can do that much better. And the storage that you can have. So that's how the machine can really give you a lot of power to analyze your data. So in conclusion, I think I don't have much to explain. So in conclusion, I just make you to understand the importance of data analytics, irrespective of the area. right from the playground, I said, from the healthcare to business and so on and so forth. If you have the insight into your data, if you understand your data well, you can really be a successful businessman. In this context, I remember what Subhash Chandra Bose said. He said, give me blood, I'll give you freedom. Today, the businessman would say, give me data, I'll give you business. Right? You can be a business, right? So this is how the things have changed. So the World Economic Forum equated data with oil. Now I'm equating data with blood. Subhash Chandra Bose said, give me blood, I'll give you freedom. Now, today's data analytics or data scientists will tell you, give me data, I'll tell you what to do, how you can be successful. And that is what Prashant Kishore is doing. Right? That's the reason that is how I started. Right? Prashant Kishore will not tell you anything from the blue. You need to tell the geographical scenarios, the topography, and various other information in that particular area. So he will tell you what exactly you're supposed to do. Anyway, I'm not doing advertising for Prashant Kishore. I just give an example because I always think how he has become so smart to explain things. Okay, young students, just now I'm addressing the young students. See, whenever somebody is talking on these areas, take those things very seriously because you don't know. One day you will land up in making a career in these areas. Because you can read from the magazines, you can read you can see from, listen from many speakers. Most of the jobs will be in this area. Either it's a using data analytics tools, different visualization tools, and things like that. So data scientists, data analytics is the future, at least in the context of India. And there are a lot of data that is floating around. I would encourage, like Sir was saying, that you start writing small programs in Python. So you have some understanding what you're doing, and slowly you can graduate to a particular level where you can add meaning to the data. Right? Data itself has no meaning, but you should know what kind of interpretation that you should add and how you can add a meaning to that. But again, there is a word of caution. Because there are many techniques around, don't get tempted to use X, Y, Z technique anywhere. You must know, don't use the technique as a black box. So if you just give your data and see some output, you get some projection, some predicted values, don't go with that. You must know which technique will fit where. That is very important. Otherwise, you must be thinking that all the techniques are all there, data are there. I can try, I can apply SVM, I can apply KNN, I can apply J48, I can apply CNN, RNN, whatever. But don't use these techniques, it's a word of caution. Don't use these techniques as a black box. Try to understand what those techniques actually do. On what kind of data those techniques will be applied in a very effective way. So in order to do that, again coming back, you cannot run away from mathematics. Right? So therefore, love mathematics, try to understand what those techniques are doing, and then you can see all these impacts coming on as a result of those algorithms, those techniques. So with this, I just stop here. If you have any question, you can ask. Or otherwise, we all go to lunch.
Thank you so much, sir, for your valuable insights on machine data, data analytics, and machine learning. I would like to take a moment to thank our esteemed keynote speakers for today. Each of them has brought a wealth of knowledge and expertise to this platform, and we are truly honored to have all of them share their insights with us. I would now request Principal Sir Dr. Sanjeev Kumar Das to give away the token of appreciation to Professor Subhashish Mahapatra. Sir, please. We would expect a huge round of applause while giving away the token of appreciation. Thank you, sir. Again, I would like to request Principal Sir Dr. Sanjeev Kumar Das to felicitate Professor Dr. Samarjit Kar, sir. Sir, please. Thank you, sir. I would request Director Sir, Mr. Soumyakanta Balwantray, to felicitate Professor Dr. Manas Ranjan Patra. Sir, please. Thank you, sir. It is now time to call upon stage for the convener of this organizing committee, Dr. Kailash Chandra Naik, to give away the vote of thanks. Sir, please.
Honorable guest of honor, distinguished keynote speaker, esteemed guests, ladies and gentlemen, good afternoon. I would like to express our deepest appreciations to our esteemed guest of honor, Professor Jaswant Jena, Director IMA Bhubaneswar, for your support and guidance. Your vision and encouragement have been instrumental in making the seminar as a resounding success. I would like to express our sincere gratitude to our three distinguished keynote speakers, Professor Dr. Manas Ranjan Patra, Professor Dr. Samrajit Kara, and Professor Dr. Subhasis Mahapatra. Your expertise, knowledge, and scholarly contribution have significantly enriched our technical session. The insight and perspective you shared during your keynote address have not only our understanding but also inspired us to explore new horizons to our respective fields. Again, I would like to thank the Chairman, Director, Principal, Academic Advisor, Sir, and all the faculty members of USBM family for your continuous effort to make this event successful. Furthermore, sincere appreciation goes out to all the participants and attendants for different colleges who have actively participated in the technical session, engaging the fruitful discussion and sharing the valuable ideas. Your presence and active involvement have contributed to overall success of this seminar. I extend my heartfelt thanks to all the sponsors, volunteer technical staffs, media personnel, and everyone who has contributed time, resource, expertise to make this seminar a grand success. Without your support, this event would not have been possible. We would also like to acknowledge the effort of our USBM family who have worked tirelessly and to plan, execute the event. Their direction, meticulous planning, and attention to detail have ensured a smooth and enriching experience. In conclusion, I would like to express our deep gratitude to all the dignitaries, speakers, and everyone who involved for making this national seminar a truly memorable and successful event. Thank you once again, and we look forward to your continued support and participation in our future endeavors. Thank you all.